Hi everyone. Hello and welcome. It is so good to have you here with me, right now in this quiet space. There is nothing you need to do, nothing you need to think about. No rush, no effort, no place you have to be. Simply rest. And maybe if you would like, we can learn something very gently together. Not to remember, not to study, but just to let the mind drift. Like a cloud moving slowly across a wide, open sky. Tonight, we're going to think about lightning, one of nature's oldest, strangest, and most beautiful dances. And we will go very, very slowly, step by step, fact by fact, like lying on soft grass and watching the clouds shift shape. There is no test at the end. There is no need to concentrate. If you drift off, that is perfect. If you stay awake, that is also perfect. This is just a soft, gentle journey into the science of why lightning happens. And so we begin, slowly, quietly, with the first fact. Let us start with something very simple. Lightning begins inside a cloud. Not just any cloud, but a very tall cloud called a cumulonimbus cloud. These clouds grow high into the sky, sometimes reaching the very top of the lower atmosphere. And inside this cloud, there is constant, gentle movement. Tiny ice crystals and small hailstones are lifted upward by warm air, and then they fall back down. Up and down, very softly like a slow elevator. As they bump into each other, something very small happens. They share tiny particles called electrons. One piece of ice gives away an electron, and another piece takes it. This is not dramatic. It is just a quiet exchange, like two people whispering. And over time, this creates two different layers inside the cloud. The top becomes slightly positive, and the bottom becomes slightly negative. And we can take a moment to notice. This is the very first spark of a lightning bolt, long before we see any flash. It begins as a tiny, invisible imbalance. Soft, quiet, and perfectly natural. Now, as we continue gently, let us think about what that imbalance really means. When we say the bottom of the cloud is negative, we mean it has more electrons than usual. And when we say the top is positive, we mean it has fewer electrons. Nature always wants balance. It is a very calm, patient rule of the universe. Everything tends toward rest, toward equality, toward soft harmony. So the cloud feels this imbalance, and it wants to fix it. The negative bottom wants to send its extra electrons somewhere that has fewer electrons. Somewhere positive. But the air between the cloud and the ground is normally a very good insulator. That means it does not like to let electricity flow through it. Air is shy. It holds back. So for a while, the cloud just waits. It builds up more and more electrons at its base, like a quiet reservoir filling with water. And the ground below, which is usually neutral, becomes positive in response. The ground is attracted to the cloud's negativity. They want to meet, but the air says not yet. Slowly, gently, there is no need to rush. And this waiting period is called the charging phase. It can last many minutes, while the cloud drifts silently across the sky. Let's take a quiet moment to think about what happens next. After enough charge builds up in the cloud, the electric field becomes very strong. Electric field is just a name for the invisible zone of influence between the negative cloud and the positive ground. It is like a gentle tension, like a stretched rubber band. But instead of rubber, it is made of air. And eventually, the air can no longer hold back. It becomes ionized, which is a soft way of saying that some of the air molecules lose an electron and become charged themselves. This creates a tiny, invisible pathway. Scientists call this a stepped leader. And the stepped leader is very shy. It does not rush down to the ground all at once. Instead, it moves in small, soft steps, maybe 50 meters at a time. Then it pauses, then another step, then another pause. It is like a careful explorer feeling the way in the dark. The stepped leader is made of negative charge, and it reaches down from the cloud toward the earth. step by gentle step. And all of this happens faster than you can blink. But if we slow it down, we can see how patient it is. Step, pause, step, pause, feeling the air, testing the path. And we can just rest with that image for a moment, gently moving forward. While the stepped leader makes its way down, something wonderful begins to happen on the ground. The positive charge on the Earth's surface reaches upward, not in one big flash, but in many small upward streams. These are called upward streamers. They are very soft and very short, rising up from tall trees, from buildings, from blades of grass, even from the tip of a leaf. Each upward streamer is like a tiny hand reaching out, hoping to touch the stepped leader. And the stepped leader coming down is also reaching. They are trying to find each other. When the stepped leader gets close enough to the ground, about 50 meters or so, one of these upward streamers finally connects. And that connection is the moment. That soft, invisible touch. That quiet handshake between the sky and the earth. Once they touch, the path is complete. The air becomes a temporary wire, and all the charge that has been waiting, patiently building in the cloud, can suddenly rush down. This rush is what we see as the bright flash of lightning. But the flash is not the beginning. The flash is the ending of a long, slow, patient dance of approach. And that is a very peaceful thought. Everything in nature takes its time, even lightning. Now let us rest here for a moment and think about what we actually see. When lightning flashes, it looks like a single bright line. But that line is not one thing. It is actually many strokes happening in the exact same channel, one after another, faster than our eyes can see. The first stroke is the one we just described, where the stepped leader connects to the upward streamer. That first stroke sends a powerful pulse of current upward from the ground to the cloud. Yes, upward. Most of the lightning you see actually goes from the ground to the cloud, not the other way around. But it happens so fast that our eyes cannot tell the direction. After that first stroke, the channel remains open. The air is still ionized, still conductive. So a second stroke can come down, using the same path. Then a third. Sometimes 5, sometimes 10, sometimes 20 strokes in a single flash. Each stroke is separated by only a few hundredths of a second. That is why lightning sometimes seems to flicker. It is not one bolt. It is a rapid series of soft pulses, like a heartbeat. Thump, thump, thump. Each one following the same gentle path. And then, when all the charge is balanced, the channel closes. The air goes back to being ordinary air, and the sky becomes quiet again. Let's take a very slow breath and think about the sound. Thunder. Thunder is not a separate event. Thunder is simply the sound of lightning. When the lightning channel heats up, it becomes incredibly hot, hotter than the surface of the sun. But we do not need to be alarmed by that number. We can just notice that when air gets very hot very quickly, it expands. It explodes outward. But the word explode sounds harsh, so let us say it pushes outward very fast. That outward push creates a shock wave, and that shock wave becomes a sound wave by the time it reaches our ears. The sound wave travels through the air at about 1 kilometer every 3 seconds. That is much slower than light. So we see the flash almost instantly, and then we wait. Slowly, gently. 1,000, 2 1,000, 3 1,000. And then we hear the rumble. The reason thunder rumbles instead of sounding like a single crack is because different parts of the lightning channel are different distances away from us. The sound from the bottom of the bolt reaches us first, then the sound from higher up, then from even higher. They arrive one after another, blending together into a long, rolling, low sound. A soft, deep voice from the sky. And if you listen carefully, thunder is not angry. It is simply the air sighing. Now, as we continue gently, let us think about why some lightning touches the ground and some does not. There are actually many kinds of lightning. The kind we have been describing, that connects the cloud to the ground, is called cloud-to-ground lightning. But there is also cloud-to-cloud lightning, which happens between two different clouds, and intracloud lightning, which happens inside a single cloud. Intracloud lightning is actually the most common kind. Most lightning never touches the ground at all. It stays entirely within the cloud, jumping from the negatively charged bottom to the positively charged top, or from one pocket of charge to another. From the ground, we sometimes see this as a soft glow inside the cloud, like a light bulb turning on and off behind a curtain. Or we see the outline of the cloud lit up from within. It is very peaceful to watch. The cloud flashes gently, like a deep, slow breath. And cloud-to-cloud lightning happens when two separate clouds have opposite charges. They reach across the gap between them. Sometimes that gap is many kilometers wide. And from far away, it looks like the clouds are quietly talking to each other, sending soft messages of light back and forth. No ground, no noise if you are far enough. Just silent, gentle conversation in the sky. Let's take a quiet moment to think about heat lightning. You have probably seen this on a warm summer night. The sky is clear where you are, but on the horizon, you see soft flashes of light, like a distant camera. No thunder, no rain, just gentle, silent flashes. This is not a special kind of lightning. It is simply ordinary lightning from a storm that is very far away, maybe 100 or 200 kilometers distant. The storm is below the horizon, so you cannot see the clouds. But the lightning flashes are so bright that they reflect off the upper atmosphere and scatter across the sky. And the thunder? The sound waves from that faraway lightning dissipate or fade away before they reach you. They travel through the air, bouncing and spreading, but they lose their energy. By the time they might have reached your ears, they are too soft to hear. So you see the light, but you hear nothing. That is why it is called heat lightning. Not because it is hotter than other lightning, but because it often happens on warm, humid nights when the atmosphere carries light far but swallows sound. So you can lie on your back, looking up at the stars, and every few seconds, a soft glow appears on the horizon. No drama, no rush, just a distant, silent greeting from a storm that does not need your attention. Gently moving forward, let us talk about the colors of lightning. Lightning is not always white. Sometimes it appears blue, sometimes purple, sometimes pink, sometimes even orange or red. The color depends on what the lightning passes through. White lightning is the most common. That is when the bolt travels through clean, clear air. But if there is a lot of moisture in the air, the lightning can look blue or purple. Water vapor scatters light in a way that favors those cooler colors. If the lightning is very close to the ground, and the air near the ground has a lot of dust or pollution, the lightning can look orange or red. That is because the dust particles absorb some of the blue light and let the red light through, much like a sunset. And sometimes if the lightning is very high up, like in the upper atmosphere, it can even look red or pink. There are also very rare forms of lightning called red sprites and blue jets. They happen above thunderstorms, reaching up toward the edge of space. They are very faint and very quick, lasting only a few thousandths of a second. Pilots and astronauts have reported seeing them. They look like huge, glowing jellyfish or carrot shapes, briefly blooming in the dark sky. And they are completely silent from the ground. Just a soft, fleeting blush of color at the top of the world. Let us rest here and think about how often lightning happens. Across the entire planet, every second of every day, there are about 50 to 100 lightning flashes. That means every minute, roughly 3,000 to 6,000 flashes. Every hour, about 200,000 flashes. Every day, nearly 5 million flashes. And every year, almost 1.5 billion flashes. That sounds like a very large number, and it is. But we can also think of it softly. The Earth is very big. Most of these flashes happen over the oceans, or over unpopulated land, or inside clouds where no one sees them. The Earth breathes electricity the way we breathe air, softly, constantly, without needing our attention. The total amount of energy in all that lightning is also very large, but it is spread out. The Earth's atmosphere is always gently rebalancing itself. Lightning is one of nature's ways of maintaining a quiet electrical equilibrium between the ground and the sky. Without lightning, the atmosphere would slowly build up an enormous electrical charge. But lightning keeps things calm, like a thermostat that turns on and off without you even noticing. So when you see a flash in the distance, you are watching the planet take a soft, steady breath. Now, as we continue gently, let us think about the temperature inside a lightning channel. It is very, very hot, around 30,000 degrees Celsius or 50,000 degrees Fahrenheit. That is about 5 times hotter than the surface of the sun. But here is a peaceful thought. That heat only lasts for a tiny fraction of a second. The lightning channel is very thin, maybe only 2 or 3 centimeters across, and the heat is concentrated in that narrow tube. The rest of the air around it stays cool. So the lightning is like a very thin, very hot needle passing through a cool blanket. And because it is so hot, the air inside the channel becomes a special state of matter called plasma. Plasma is like a gas, but the atoms have been stripped of their electrons. They are just bare nuclei swimming in a sea of loose electrons. Plasma is the most common form of visible matter in the universe. Stars are made of plasma. Nebulas are made of plasma. So when you see lightning, you are seeing a tiny piece of a star right here on Earth for just a moment. And then it fades. The plasma cools. The electrons rejoin their atoms. The air becomes normal air again. It is a brief, beautiful return to ordinary rest. Let's take a slow, quiet moment to think about the sound of lightning up close. If you are very close to a lightning strike, the thunder does not rumble. It cracks. It is a sharp, loud sound like a whip or a gunshot. But we do not need to be afraid of that. Even close lightning is just physics. The crack happens because the part of the lightning channel nearest to you makes a shockwave that reaches your ears almost instantly, before it has had time to spread out and soften. From farther away, the sound waves have bounced off hills, buildings, clouds, and the ground. They have taken different paths. Some arrived early, some late. And that spreading out in time is what turns the crack into a rumble. So if you hear a long, rolling thunder, you are far enough away to be safe. The lightning is several kilometers from you, and you can count the seconds between the flash and the sound. Each 3 seconds is about 1 kilometer, but you do not need to count. You can just listen. The thunder will tell you how far the lightning has traveled. And as the storm moves away, the thunder becomes softer and softer, lower and lower, until it is just a distant murmur, like the ocean in a shell. Then silence. Then the gentle sound of rain. Gently moving forward, let us talk about the connection between lightning and volcanoes. Volcanoes can produce lightning too, but not from thunderclouds. Volcano lightning comes from the ash cloud itself. When a volcano erupts, it blasts millions of tiny pieces of rock, ash, and glass into the air. These particles rub against each other with great force. And just like ice crystals in a thundercloud, they exchange electrons. Some particles become positively charged, some negatively. The heavy ash cloud becomes a giant battery. And eventually, the charge builds up so much that it discharges as lightning. This volcano lightning happens right inside the ash plume, sometimes very close to the volcano's crater. It can be incredibly beautiful. Photographs show bolts of lightning branching through a dark, towering cloud of ash, with red lava glowing below. But we can also think of it softly. The Earth has many ways of releasing energy. Volcanoes release heat. Thunderstorms release electricity. And sometimes they happen together, creating a rare and spectacular display. Yet even that display is just nature balancing itself. The ash wants to settle. The charge wants to neutralize. The lightning helps that happen a little faster. Then the ash falls gently to the ground, like snow, and everything becomes quiet again. Let us rest and think about lightning on other planets. Earth is not the only place where lightning happens. Space probes have detected lightning in the atmospheres of Jupiter, Saturn, Uranus, and Neptune. Jupiter's lightning is the most powerful. Each Jovian lightning bolt can be up to 1,000 times more energetic than an Earth bolt. And Jupiter's lightning happens deep in its atmosphere, where the pressure is very high, and the clouds are made of ammonia and water. Saturn also has lightning, but it is less frequent. Scientists have listened to Saturn's lightning using radio waves. It sounds like static or soft pops, or the crackle of a fireplace. Uranus and Neptune have lightning too, but it is much rarer. The atmospheres of those ice giants are very cold and very calm. Their lightning is faint and infrequent. And we have also seen evidence of lightning on Venus, though it is still debated. Venus has a thick, heavy atmosphere of carbon dioxide and sulfuric acid clouds. If lightning happens there, it would be hidden beneath the clouds, invisible from space. So lightning is not just an Earth thing. It is a planetary thing. Wherever there are clouds and moving particles, there is the potential for a soft, electrical dance. The universe is full of quiet sparks. Now, as we continue gently, let us think about the very first time humans studied lightning scientifically. For most of history, people believed lightning was caused by angry gods. The ancient Greeks thought Zeus threw lightning bolts. The Norse thought Thor threw his hammer. But then, in the 1700s, a man named Benjamin Franklin became curious. He suspected that lightning was a form of electricity, the same kind of electricity that makes a spark when you rub your feet on a carpet. He did not discover this by flying a kite in a storm. That story is mostly a myth. What he actually did was propose an experiment. He thought that if he flew a kite into a thunderstorm, the metal key on the string would draw electricity from the clouds. And it worked, but he was very lucky not to be killed. Later, he invented the lightning rod, which is a metal pole placed on top of buildings. The lightning rod attracts lightning and safely guides the electricity into the ground, protecting the building. That was the first time humans learned to control lightning, not through magic, but through quiet understanding. And that is a very peaceful idea. We do not need to fear what we can understand. We can simply learn, slowly, gently, and find ways to be safe. Let's take a quiet moment to think about the lightning rod itself. A lightning rod is a very simple device. It is just a sharp metal rod attached to the highest point of a building, connected by a thick metal wire to a metal rod buried in the ground. When a thunderstorm passes overhead, the electric field around the building becomes stronger. But lightning rods work not by attracting lightning, but by giving lightning an easy path. If lightning strikes near the building, the rod offers a low-resistance route to the ground. The electricity prefers the metal path because metal conducts electricity much better than wood, brick, or stone. So the lightning flows down the rod and into the earth, where it spreads out harmlessly. The building is untouched. The people inside are safe. And the lightning rod does not spark or sizzle. It just quietly does its job. You can see lightning rods on many old buildings, churches, barns, and houses. They are like quiet guardians. They do not shout. They do not fight. They simply offer a gentle path. And that is a beautiful lesson from nature. Sometimes the best way to handle a powerful force is not to block it, but to give it a safe way to pass through. Gently moving forward, let us talk about the electrical field of the Earth even when there is no storm. On a perfectly clear, sunny day, there is still an electric field between the ground and the sky. The Earth's surface is negatively charged, and the upper atmosphere is positively charged. The difference is about 100 volts for every meter of height. That means between your head and your feet, there is about 200 volts of electrical difference. But you never feel it because your body is a conductor, and the voltage is spread out evenly. This global electric field is maintained by thunderstorms. Thousands of storms around the world are constantly pumping positive charge into the upper atmosphere and negative charge into the ground. The air itself is a very poor conductor, but it is not a perfect insulator. There is a very, very slow current flowing from the sky to the ground everywhere on Earth. It is called the fair weather current, and it is incredibly weak. It would take 1,000,000 years to light a single light bulb. So you can imagine the whole planet wrapped in an invisible, gentle electrical blanket. A soft, steady, silent flow that never stops, day or night, storm or shine. And you are part of that flow. Your body is part of the Earth's quiet electrical breath. Let us rest here and think about the sound of a distant thunderstorm at night. There is something very peaceful about it. You are inside, warm and dry. The storm is far away, maybe behind a hill or across a valley. And you hear the thunder as a low, continuous rumble, like a giant rolling a barrel across a wooden floor. Sometimes it fades almost to nothing, then returns a little louder. The lightning flashes are soft, illuminating the edges of the clouds, turning them silver for just a moment. Then darkness. Then another flash. The rain might reach you eventually, or it might not. It does not matter. You are safe. You are still. And the storm is doing exactly what storms do. It is releasing energy. It is balancing charge. It is watering the earth. It is not angry. It is not trying to scare you. It is just a natural process, like the tide coming in or the wind moving through the pines. And you can listen to it the way you listen to a lullaby, without understanding every word, just feeling the rhythm, the low, soft, patient voice of the sky saying, "Rest. Rest. There is nothing you need to do." Now, as we continue gently, let us think about the shape of lightning. Lightning is not straight. It branches. It zigzags. It forks into many paths like the roots of a tree or the branches of a river. This happens because the stepped leader is always looking for the path of least resistance. Air is not uniform. Some pockets of air are slightly warmer, slightly more humid, slightly more ionized than others. The stepped leader feels these differences. It turns toward the easier path, the path where the air is slightly more willing to conduct electricity. Then it pauses. Then it turns again. Each turn is a small decision, made not by a brain but by physics. The result is a beautiful, jagged shape that we recognize instantly. No two lightning bolts are exactly alike. Each one is a unique fingerprint of the air it passed through. And scientists can actually reconstruct the electric field by looking at the shape of the lightning. The bends and branches tell a story about the temperature, the humidity, the pollution, and the wind in that particular moment in that particular piece of sky. So every lightning bolt is a kind of map, a drawing made by the air itself. And then it fades. But for a split second, it is a perfect natural work of art. Let's take a slow, quiet moment to think about positive lightning. Most lightning is negative lightning, meaning the stepped leader carries negative charge down from the cloud. But about 5 to 10% of lightning is positive. In positive lightning, the stepped leader comes from the top of the cloud, which is positively charged and carries positive charge down to the ground. Positive lightning is much more powerful than negative lightning. It can carry 10 times more current. It lasts longer, and it often strikes far away from the storm center, sometimes tens of kilometers ahead of the rain. People call these bolts out of the blue because they seem to come from a clear sky. But the sky is not truly clear. The storm is just far away. Positive lightning is also more dangerous because it is stronger and harder to predict. But we do not need to be frightened. We can just notice the difference. Positive lightning happens when the positive charge at the top of the cloud becomes so large that it overcomes the negativity in the middle. It reaches down through the cloud, ignoring the negative region, and finds a path to the ground. It is rare. It is powerful. And even positive lightning follows the same basic rule. nature wants balance. The positive cloud and the negative ground want to meet. And when they do, the flash is brighter and the thunder is louder. But then it is over. Balance is restored. Gently moving forward, let us talk about ball lightning. This is one of the rarest and strangest forms of lightning. People have reported seeing glowing balls of light, about the size of a grapefruit or a beach ball, floating slowly through the air. Sometimes they appear after a lightning strike. Sometimes they appear inside houses or even inside airplanes. The balls are usually orange, yellow, or red. They hover. They drift. They might hiss or buzz softly. Then, after a few seconds, they disappear, sometimes silently, sometimes with a small pop. For centuries, scientists did not believe ball lightning was real. They thought it was an illusion or a trick of the eyes. But now, most scientists agree that it is a genuine, though very rare, phenomenon. There are many theories about what causes it. Some think it is a cluster of ionized air, glowing because of chemical reactions. Others think it is a tiny ball of plasma trapped in a thin shell of cool air. Some think it is caused by vaporized silicon from soil turning into a glowing aerosol. But no one knows for sure. And that is a very peaceful mystery. There are still things in nature that we do not fully understand. The world is not a closed book. It is a soft, open, wondering place. And ball lightning is one of its quietest, most mysterious visitors. Let us rest and think about how lightning affects the air around it. When lightning strikes, it does more than just create light and sound. It also creates chemicals. The intense heat breaks apart nitrogen molecules in the air. Normally, nitrogen gas is made of two nitrogen atoms stuck together. They do not like to separate, but the lightning channel is so hot that the bonds break. The free nitrogen atoms then react with oxygen to form nitrogen oxides. These nitrogen oxides dissolve in rainwater and fall to the ground. And once in the soil, they become nitrates, which are a type of plant fertilizer. So lightning actually helps plants grow. Every year, lightning produces about 5 to 10% of the world's natural nitrogen fertilizer. That is millions of tons. So when you see a thunderstorm, you are watching the sky gently feeding the earth. The rain that falls after a storm is richer in nitrogen than ordinary rain. It is like a soft, invisible gift from the clouds. The grass grows greener. The crops are healthier. And all because of a flash of light and a moment of heat. Nature is very clever. Even something as powerful as lightning has a quiet, nurturing side. It is not just destruction. It is creation too. Slow, steady, unseen creation. Now, as we continue gently, let us think about lightning and trees. Trees are often struck by lightning because they are tall and pointed, and they are full of water and sap. Water is a conductor, so a tree is a good path for lightning to reach the ground. When a tree is struck, the lightning travels down through the trunk, just under the bark. The sap inside the tree heats up instantly and turns to steam. The steam expands rapidly, and the force of that expansion can blow the bark off the tree in long vertical strips. The tree might survive. Many trees do. You can see the scars on old trees, long wounds in the bark that heal over time. But sometimes the tree dies. The lightning cooks the living layer just under the bark, and the tree can no longer transport water from the roots to the leaves. Over the next few months, the leaves turn brown, and the tree slowly fades. But there is a softer way to see this. The tree accepts the lightning without fighting. It does not run away. It does not complain. It simply stands where it has stood for decades, and if lightning chooses it, the tree becomes a part of the sky's electrical story. And then the tree falls and rots and becomes soil for new trees. That is the gentle cycle of life. Nothing is wasted. Everything returns. Let's take a quiet moment to think about lightning safety. This is not a scary topic. It is just a gentle reminder. When a thunderstorm is near, the safest place to be is inside a large, enclosed building with wiring and plumbing. The metal pipes and wires act like a giant lightning rod system, carrying any strike safely into the ground. The second safest place is inside a metal-topped vehicle, like a car or a truck. The metal shell directs the electricity around the outside of the vehicle, leaving the inside safe. The most dangerous places are open fields, hilltops, and under isolated trees. But we do not need to be afraid. We can simply pay attention. If you hear thunder, the lightning is close enough to reach you. Go inside. Wait 30 minutes after the last thunder before going back out. That is all. There is no need to panic. The storm is not hunting you. It is just doing its work. And you can honor that work by giving it space. By staying cozy inside with a warm drink, listening to the rain. That is not fear. That is respect. And respect is a very calm, peaceful feeling. You are safe. The storm will pass. And you will have been kind to yourself. Gently moving forward, let us talk about lightning and the ocean. Lightning strikes the ocean all the time. But the ocean is huge, and the strikes are spread out. When lightning hits the water, the electric current spreads out in all directions. Salt water is a good conductor, so the current travels far. But it also weakens quickly with distance. Within about 10 meters of the strike, the current is still strong enough to be dangerous to fish or swimmers. Beyond that, it is harmless. The ocean does not care about lightning. It is too big, too deep, too old. A lightning bolt over the ocean looks beautiful from a ship or from the shore. The flash reflects off the waves, and the thunder echoes across the water. And sometimes on very dark nights, sailors report seeing St. Elmo's fire. That is a different phenomenon, not lightning itself, but a soft blue glow that appears at the tips of masts and rigging during a thunderstorm. It is caused by the same electric field that produces lightning, but without the bolt. The field is strong enough to make the air glow like a neon sign. Sailors used to see it as a good omen, a sign that their ship was safe from lightning. And for the most part, they were right. St. Elmo's fire means the electric field is high, but the lightning has not struck. It is the sky whispering, not shouting. Let us rest and think about the sound of lightning from very far away. If you are 100 kilometers from a storm, you cannot hear the thunder at all. The sound waves have spread out and weakened into nothing, but you might still see the light. That is heat lightning, as we talked about earlier. But if you are 200 kilometers away, you cannot even see the light. The storm is below the horizon, yet the lightning is still there. It is flashing. It is rumbling. It is producing nitrogen fertilizer. It is doing all the things lightning does, and you are completely unaware of it. That is a peaceful thought. So many things are happening in the world that we do not see or hear. So many storms are passing far away, over empty oceans or unvisited forests. The planet is alive with electricity, and most of it happens in silence, unseen. You do not need to witness everything. You do not need to know everything. You can simply rest in your small, quiet corner of the world, knowing that the sky is taking care of itself. The storms will come and go. The lightning will flash. And you can sleep through it all, or wake just enough to hear a distant rumble, and then sink back down into warmth and softness. Now, as we continue gently, let us think about the speed of lightning. The visible flash moves at nearly the speed of light. That is about 300,000 kilometers per second, or 186,000 miles per second. It is so fast that you cannot see it move. Your eye sees the entire flash at once, even though the lightning actually travels from the cloud to the ground in about 1/10,000th of a second. But the stepped leader, the invisible pathfinder that comes before the flash, is much slower. It moves at about 100 to 1,000 kilometers per second. That is still incredibly fast, faster than a jet airplane, but slow compared to light. And the upward streamers move even slower. They creep upward at maybe 10 kilometers per second. So lightning has two speeds. A slow, patient feeler that finds the way, and then a blindingly fast rush of power that follows the path. It is a little like walking carefully down a dark staircase, and then once you know the steps, you can run. The stepped leader is the careful walk. The return stroke is the run, and both are necessary. Without the patient feeler, the runner would have no path. Without the runner, the feeler would just be a weak, invisible trail. Together, they make lightning. Let's take a slow, quiet moment to think about the sound of thunder underwater. If you are swimming in the ocean or a lake during a thunderstorm, you will not hear the thunder in the same way. Sound travels differently in water. It moves faster, about 4 times faster than in air. But the lightning strike happens in the air, above the water. The sound waves hit the water's surface. Some of the sound energy is reflected back into the air. Some is transmitted into the water. What you hear underwater is a strange, muffled, low-pitched sound, like a distant drum being beaten underwater. It is softer and less distinct than thunder in air. But you also feel it. The low-frequency sound waves vibrate your whole body. It is a gentle, rumbling sensation, like lying on a very large, very slow speaker. And if the lightning strikes the water very close to you, you would feel a sharp shock. That is why it is safest to be out of the water during a storm. But from a distance, underwater thunder is a curious, peaceful thing. It reminds you that sound is just vibration, and vibration travels through everything. Air, water, your bones, the earth. Everything is connected by invisible waves. Gently moving forward, let us talk about the difference between lightning and other electrical sparks. A static electricity spark, like when you touch a doorknob after walking on a carpet, is the same basic thing as lightning. It is a flow of electrons between 2 objects with different charges. The only differences are scale and energy. The carpet spark might carry a few thousand volts. Lightning carries hundreds of millions of volts. The carpet spark jumps a few millimeters. Lightning jumps several kilometers. The carpet spark lasts a microsecond. Lightning lasts milliseconds. But the physics is the same. The same rules of attraction and repulsion. The same need for balance. So every time you get a small shock from a shopping cart or a car door, you are experiencing a tiny, harmless piece of lightning. You are a miniature thunderstorm. Your body, your clothes, the air around you, all participating in the same quiet dance. And that is a very grounding thought. You are not separate from nature. You are made of the same electrons, the same charges, the same longing for rest. That little spark on your fingertip is just a whisper of the great flashes in the sky. And the great flashes are just louder versions of that whisper. All one family. Let us rest and think about how lightning affects animals. Many animals can sense a thunderstorm coming before humans can. Birds, for example, are very sensitive to changes in air pressure and static electricity. They often fly low or take shelter long before the first raindrop falls. Dogs and cats can hear thunder from much farther away than we can. Their ears are tuned to higher frequencies, and they feel the low rumble in their bones. Some animals, like elephants and baboons, seem to use thunder as a cue to move toward water sources during dry seasons. They know that rain follows thunder, and there is a fascinating phenomenon called earthquake lights that some people believe animals can sense before an earthquake. Earthquake lights are rare, glowing flashes in the sky that sometimes appear before or during large earthquakes. They look a bit like lightning, but they come from the ground, not the clouds. The theory is that stress in the Earth's crust creates electrical charges that discharge into the air. Animals may feel these charges through their whiskers or fur. But even without that, the animal world is deeply connected to the sky. They do not fear lightning the way we sometimes do. They simply respond. They move. They hide. They wait. And then, when the storm passes, they go back to their lives. Quietly. Naturally. Now, as we continue gently, let us think about the history of lightning research after Benjamin Franklin. In the 1800s and 1900s, scientists began to measure lightning more precisely. They built tall towers on mountaintops and waited for lightning to strike them. One famous scientist, Nikola Tesla, tried to send wireless electricity through the air using giant coils that produced artificial lightning. He dreamed of a world where power was transmitted without wires, through the air itself. He built a laboratory in Colorado Springs and generated bolts of electricity over 40 meters long. People could see the flashes from miles away. But even Tesla could not control natural lightning. No one can. We can only measure it, understand it, and protect ourselves from it. The most important tool for studying lightning today is the Lightning Detection Network. This is a system of sensors placed all over the world that listen for the radio waves produced by lightning. Every lightning flash makes a very specific radio signal, called a spheric. The sensors detect these spherics, measure the time they arrived, and triangulate exactly where the lightning struck. Within seconds, the information is available online. So you can watch a map of the world and see every lightning flash, in real time, as tiny dots of light. It is like watching the earth breathe. Let's take a quiet moment to think about the radio sounds of lightning. If you have an AM radio, you can hear lightning even when it is far away. Turn the radio to a quiet frequency between stations where there is only static. When lightning flashes nearby, the static changes. It becomes a soft crackle or a pop or a series of clicks. That is the radio wave from the lightning reaching your radio. Sometimes, if the lightning is far away, the sound is a long, drawn-out hiss, like bacon frying softly. Radio amateurs often use these sounds to find thunderstorms. They call them tweaks and whistlers. A tweak is a short, descending tone caused by the radio wave bouncing off the lower edge of the ionosphere. A whistler is a longer, musical tone that can last for a second or more. Whistlers are produced by lightning that travels along the Earth's magnetic field lines, going up into space and back down to the other hemisphere. You can hear them on special receivers. They sound like a soft, falling whistle from high to low, like a small, sad bird. And they are one of the most beautiful sounds in all of nature. A lightning bolt singing as it travels through the magnetosphere. Gently moving forward, let us talk about the connection between lightning and cosmic rays. Cosmic rays are high-energy particles that come from space, from exploding stars and distant galaxies. They are always raining down on Earth. Most pass right through you without you noticing. But sometimes, a cosmic ray will hit a molecule in the upper atmosphere and create a shower of secondary particles. Some of these particles can ionize the air, meaning they knock electrons off atoms. This creates a tiny, weak path of conductive air. And some scientists believe that these cosmic ray paths can help trigger lightning. The cosmic ray creates a small channel of ionized air, and then the thunderstorm's electric field uses that channel as a starting point. The stepped leader follows the cosmic ray's trail. If that is true, then some lightning bolts are partly caused by particles from distant supernovas, stars that exploded millions of years ago. So when you see lightning, you might be seeing the ghost of an ancient star reaching across the universe to touch the Earth. That is a very quiet, enormous thought. The sky is not just above you. The sky is everything, and everything is connected. Let us rest and think about the smell of lightning. Have you ever noticed a strange, clean, sharp smell after a thunderstorm? That smell is often called petrichor, but petrichor is the smell of rain on dry earth. The smell of lightning itself is different. It is called the smell of ozone. Ozone is a molecule made of 3 oxygen atoms instead of the usual 2. Lightning creates ozone when the intense heat breaks apart ordinary oxygen molecules, and the free oxygen atoms combine with other oxygen molecules to form O3. Ozone has a very distinct smell. It is sharp, metallic, a bit like chlorine or bleach but cleaner. You can sometimes smell ozone near old electrical motors, photocopiers, or air purifiers. And you can smell it near lightning. The smell lingers after a storm, especially in the air near the ground where the lightning struck. It is a faint, crisp scent, like the air has been washed with electricity. Some people find it refreshing, others find it a little strange, but it is a sure sign that lightning has been near. The air remembers. Even after the flash is gone, even after the thunder has faded, the molecules of the air have been changed. They carry the memory of that hot, bright moment. And slowly, over minutes or hours, the ozone breaks down back into ordinary oxygen. The air forgets, and everything returns to normal. Now, as we continue gently, let us think about lightning and the ozone layer. The ozone layer is a region of the upper atmosphere, about 15 to 35 kilometers above the ground, that contains a higher concentration of ozone. This ozone layer protects life on Earth by absorbing most of the sun's harmful ultraviolet radiation. Without it, the surface would be too harsh for most living things. But lightning mostly makes ozone close to the ground, not in the upper atmosphere. Ground-level ozone is actually a pollutant. It can irritate your lungs and damage plants. So the same molecule that protects us in the sky is harmful near the ground. That is a gentle reminder that context matters. The same thing can be helpful or harmful depending on where it is and how much of it there is. Lightning produces about 10 to 20 million tons of nitrogen oxides each year, and those nitrogen oxides influence the amount of ozone in both the lower and upper atmosphere. The relationship is complex. Scientists are still studying it, but we do not need to understand all the details. We can just appreciate that lightning is part of a huge, beautiful, complicated system. The sky, the ground, the air, the living things. All connected, all influencing each other. Softly, constantly. Let's take a slow, quiet moment to think about lightning in art and culture. Human beings have always been fascinated by lightning. It appears in cave paintings, in ancient myths, in national flags, in corporate logos. The lightning bolt is a symbol of power, of speed, of sudden insight. We say someone has a lightning-fast mind. We say a flash of inspiration. The word electricity itself comes from the Greek word for amber, because the ancient Greeks discovered that rubbing amber with fur produced static electricity. They did not know it was the same as lightning, but they were curious, and curiosity is a very gentle thing. It does not shout, it just wonders. In many cultures, lightning is seen as a messenger from the gods. In some Native American traditions, lightning is a helper that clears the way for new growth. In Hinduism, the god Indra wields the thunderbolt. In Norse mythology, Thor's hammer, Mjolnir, creates lightning when it strikes. These stories are not wrong. They are poetic. They are ways of saying that lightning is important, powerful, and beautiful. And science does not take that beauty away. Science just adds another layer. Another way of saying, look how amazing this is. Look how it works. And still, after all our understanding, lightning remains beautiful. A bright, branching, momentary flower in the dark sky, gently moving forward. Let us talk about the most lightning-prone place on Earth. That place is Lake Maracaibo in Venezuela. Over the Catatumbo River, where it flows into the lake, there is a persistent thunderstorm that produces lightning almost every night of the year. On average, there are about 300 lightning flashes per square kilometer per year. That is the highest rate in the world. The phenomenon is called the Catatumbo lightning. It can be seen from over 400 kilometers away. Sailors used it as a natural lighthouse. The lightning occurs because the lake is surrounded by mountains, and warm, moist air from the lake rises and meets cooler air from the mountains. The winds push the air into a specific pattern that creates thunderstorms night after night. The lightning is mostly cloud to cloud, not cloud to ground. It flickers silently on the horizon, sometimes for hours. And it is completely predictable. You can set your watch by it. For the people who live near Lake Maracaibo, the lightning is not a threat. It is a companion. a nightly light show, a soft, flashing presence that reminds them the world is alive. And they have learned to live with it, to accept it, to even love it. That is a peaceful way to be. Let us rest and think about the least lightning-prone place on Earth. That is the Arctic and Antarctic, especially the interior of the ice sheets. Lightning requires warm, moist air rising quickly. In the polar regions, the air is cold and dry, and there is very little rising motion. So lightning is extremely rare. In the high Arctic, you might go years without hearing a single clap of thunder. When lightning does occur near the poles, it is often a surprise, a strange and alien event. The animals there are not adapted to lightning. They have no fear of it because they almost never see it. The sky is quiet. The only flashes are the auroras, which are a different phenomenon altogether. Auroras are caused by charged particles from the sun interacting with the Earth's magnetic field. They are soft, flowing curtains of green, red, and purple. They move slowly like silk in water. Lightning is sharp and fast. Auroras are slow and gentle. So if you ever find yourself in the Arctic on a summer night, you will not see lightning. You will see the aurora, maybe, and you will hear nothing but the wind and the occasional crack of ice. That is a different kind of beauty, a quieter beauty. But lightning belongs to the warm places, to the tropics, to the summer afternoons, to the places where the air is thick and the clouds grow tall. Now, as we continue gently, let us think about the height of lightning. The typical lightning bolt reaches from a cloud base at about 3 kilometers above the ground to the ground itself. So the visible part of the bolt is about 3 kilometers long. But the stepped leader starts much higher, inside the cloud, sometimes at 10 or 12 kilometers. So the total in-cloud portion of the bolt can be much longer. Some very powerful lightning bolts have been measured at over 100 kilometers long. These are called megaflashes. In 2020, scientists confirmed a lightning bolt in Brazil that stretched 709 kilometers from end to end. That is longer than the entire country of Italy. It was not a single straight line. It was a network of branches spreading across the sky like a giant tree. The flash lasted for over 16 seconds. That is an incredibly long time for lightning. Most flashes last less than a second. But this mega flash was different. It was slow, sprawling, almost lazy. It moved across the sky without urgency, like a river finding its way to the sea. And it reminds us that lightning is not always a quick crack. Sometimes it is a long, patient, wandering light. And that is a nice thought before sleep. Even lightning can take its time. Let's take a quiet moment to think about the color of the sky before a lightning storm. The sky turns strange colors before a thunderstorm. Sometimes it becomes green, sometimes yellow, sometimes a deep, bruised purple. The green color is especially striking. It happens when the sun is low on the horizon, near sunset, and the storm clouds are very tall. The red and orange light from the setting sun passes through the clouds, but the water droplets in the clouds scatter the blue light. When red and blue mix, they make purple. But the green color appears when there is also a lot of ice in the clouds. The ice scatters light differently. The combination of sunlight, water, and ice can produce a pale, eerie green glow. People who see it often say it feels strange, like the world is holding its breath. But there is nothing to fear. It is just optics, the same physics that makes rainbows and sunsets. And after the green sky, the storm comes. The rain, the wind, and then the lightning. But the green sky is not a threat. It is a warning, yes, but a beautiful warning. A sign that something is about to change. And change is not scary. Change is just the world moving from one state to another. Like falling asleep. Like waking up. Like the sky turning from green to gray to black, and then flashing white. Gently moving forward, let us talk about lightning and the water cycle. Lightning is not directly involved in the water cycle, but it is often present during the most intense parts of it. The water cycle is the continuous movement of water from the ocean to the sky to the land and back again. The sun heats the ocean, water evaporates, rises, cools, condenses into clouds, and then falls as rain or snow. Thunderstorms are the most powerful expression of that cycle. In a thunderstorm, warm, moist air rises so quickly that it reaches the top of the troposphere in less than an hour. The water vapor condenses into ice, releasing heat. That heat makes the air rise even faster, and the lightning comes along for the ride. It is a passenger in a much larger journey. Water goes up, water comes down, and in between there is light and sound. But the water does not need the lightning. The lightning is just a side effect, a beautiful side effect, like foam on the waves or sparks from a fire. The water cycle would continue without lightning. But lightning adds something, a brief, bright punctuation mark in the long, slow sentence of rain. And then the water falls to the ground, seeps into the soil, flows to the rivers, returns to the ocean, and waits to rise again. The cycle never ends. Let us rest and think about lightning in deserts. Deserts are dry, so thunderstorms are rare. But they do happen. When a thunderstorm forms over a desert, it is often a special event. The air near the ground is hot, but the air above is cool. That difference can create powerful updrafts. The rain falls, but much of it evaporates before reaching the ground. That is called virga. You see curtains of rain hanging from the clouds, but they never touch the earth. And the lightning from these storms can be spectacular. With no trees or buildings in the way, you can see the lightning from horizon to horizon. The bolts stretch across the wide, empty sky, and the thunder echoes across the canyons and mesas. There is no sound softer than thunder in the desert. It bounces off the rocks, returns, bounces again, and slowly fades into a low, distant murmur. And because the desert is so quiet, the thunder seems louder than it would in a city. Not aggressive, just present, insistent. And then the storm passes. The clouds dissolve. The sun comes out, and the desert returns to its dry, patient stillness. The lightning has come and gone, leaving nothing behind but a few scorched stones and the memory of light. Now, as we continue gently, let us think about lightning in the mountains. Mountains attract lightning because they are tall. The highest peaks are often struck many times each year. Mountain climbers have to be very careful. If a thunderstorm approaches while you are on a ridge or a summit, you are the highest point for kilometers. You become a lightning rod. Experienced climbers start their descents early, before the afternoon storms form. But from a distance, lightning on a mountain is beautiful. You see the storm cloud sitting on the peak like a hat. The lightning strikes the summit again and again. The thunder rolls down the valleys, echoes off the walls, and sounds like a drum being beaten in a stone room. And sometimes, if you are in the valley, you see the lightning hit the mountain, and then, a few seconds later, you hear the crack. Then the rumble. Then the silence. And the mountain does not move. The mountain does not care. It has been hit by lightning 1,000,000 times. It will be hit 1,000,000 more. The lightning leaves small scars on the rocks, tiny glassy spots where the heat melted the stone. Those spots are called fulgurites. We will talk about them later. But for now, just imagine the mountain, patient and massive, absorbing the sky's electricity without complaint. That is strength. Quiet, ancient, unmoving strength. Let's take a slow, quiet moment to think about fulgurites. Fulgurites are hollow glass tubes formed when lightning strikes sand or soil. The lightning channel is so hot that it melts the sand or soil instantly. The melted material flows around the bolt and then cools almost as quickly, forming a glassy, branching tube that follows the path of the lightning. Fulgurites look like rough, twisted, fragile roots. They can be as thin as a pencil or as thick as an arm. Some are only a few centimeters long. Others have been found that are several meters long. They are usually gray, brown, or black on the outside, but the inside is often smooth and shiny, like the inside of a bottle. When you hold a fulgurite, you are holding a fossil of a lightning bolt. You are touching the moment when the sky and the earth met. The sand remembers. The glass preserves that memory for thousands of years. People find fulgurites on beaches, in deserts, and anywhere else there is sandy soil and frequent lightning. And each one is unique. No two lightning strikes are the same, so no two fulgurites are the same. They are nature's signature. Quick, hot, and then frozen in time. Gently moving forward, let us talk about lightning and climate change. As the Earth's climate warms, scientists expect that lightning will become more frequent. Warmer air can hold more moisture. More moisture means more energy for thunderstorms. More energy means stronger updrafts. Stronger updrafts mean more ice collisions inside clouds. More ice collisions mean more charge separation. And more charge separation means more lightning. Some models predict that for every degree Celsius of warming, lightning strikes could increase by about 10 to 12%. That is a significant increase. Over the next century, we might see 50% more lightning in some parts of the world. But this is not something to fear. It is just a change. The Earth has had different climates in the past. There have been warmer periods and cooler periods. Lightning has always been there, adjusting to the conditions. And humans will adapt. We will build better lightning protection. We will be more careful during storms. And we will continue to watch the sky with wonder. The increase in lightning might also mean more wildfires, because lightning is a major cause of fires in dry forests. That is a challenge, but it is also a natural process. Fire clears old growth, returns nutrients to the soil, and makes way for new plants. The earth knows how to heal. It always has. Let us rest and think about lightning-caused fires. Many of the world's forests burn naturally because of lightning. In fact, lightning is the leading cause of natural wildfires. When lightning strikes a tree, it can ignite the wood instantly. Or the lightning can strike the ground and ignite dry grass or dead leaves. The fire spreads slowly at first, then faster if the wind picks up. And these fires are not bad. They are necessary. Many tree species, like the giant sequoia, need fire to open their cones and release their seeds. The fire clears away smaller plants that compete for water and sunlight. It leaves behind a rich bed of ash that fertilizes the soil. Animals that can run or fly escape. The ones that cannot, well, they become part of the cycle. Nature does not waste. After the fire, the forest grows back. It takes years, decades, sometimes centuries. But it grows. And the lightning that started the fire? That was just a moment. A flash. A crack. And then the fire does the rest. Slowly, patiently, reshaping the land. So when you see a lightning strike on a distant hillside, you might be watching the beginning of a story that will unfold over generations. A story of destruction and renewal, of ash and green, of silence and then bird song. Now, as we continue gently, let us think about how airplanes deal with lightning. Airplanes are struck by lightning surprisingly often. On average, every commercial airliner is struck about once per year. But the planes are designed to handle it. The outer skin of the plane is made of aluminum or carbon fiber, which conducts electricity. When lightning hits the plane, the current flows along the outside of the fuselage and exits through a special metal point on the tail or the wing tip. The electricity never enters the cabin. The passengers might see a bright flash and hear a loud bang, but they are safe. The plane's electronics are shielded. The fuel tanks are protected. After the strike, the plane lands normally, and mechanics inspect it for small burn marks or pitted metal. Sometimes they find a tiny hole where the lightning entered or exited, smaller than a pencil eraser. That is all. The plane is repaired and returned to service. So when you are flying in a storm, you can rest easy. The plane has been tested to withstand much more than nature usually delivers. The pilots may even see St. Elmo's fire dancing on the windshield. A soft, blue glow that means the electric field is strong, but the lightning has not yet struck. It is a reminder that even at 10,000 meters, you are still inside the sky's quiet conversation. Let's take a quiet moment to think about lightning and the human body. The human body is mostly water, and water conducts electricity. So if lightning strikes you directly, the current will pass through your body. This is very dangerous, but most people who are struck by lightning do not die. About 90% survive. They often have burns, memory loss, and other long-term effects. But they live. The lightning usually travels over the outside of the body, along the skin, because the skin has more resistance than the inside. This is called flashover. The current goes around the body rather than through it. Still, the shock can stop the heart or damage the nervous system. That is why you should never be outside during a thunderstorm. But if you are struck, the best thing to do is to have someone perform CPR and call for help. And there is a strange fact. People who are struck by lightning sometimes have branching scars called Lichtenberg figures. These are red, feathery patterns on the skin that look like ferns or tree branches. They are not burns. They are the pattern of blood vessels that ruptured under the skin. They fade after a few days. But for a little while, the person carries a map of the lightning on their body, a temporary tattoo from the sky. Gently moving forward, let us talk about hearing thunder through the ground. Sound travels through the ground too, not just through the air. When lightning strikes the ground, some of the sound energy goes into the earth. The ground vibrates at very low frequencies, below what humans can hear. But some animals can feel it. Elephants, for example, can detect these low-frequency vibrations through their feet. They can sense a thunderstorm from over 100 kilometers away. They feel the thunder before they hear it, and they may use that information to find water. Thunder means rain, and rain means water in dry riverbeds. So elephants walk toward the storm, slowly, patiently, following the vibrations through the ground. Humans can also feel thunder if we are lying on the ground. On a quiet night, with your ear to the earth, you might feel a faint, deep rumble before you hear the sound in the air. It is a different kind of thunder. Slower, lower, like the earth is humming. And if you are very still, you can feel it in your bones. That is a very old feeling. Your ancestors felt it too. They did not know what it was. They just knew that something big was happening. Something beyond them. Something that demanded respect. Let us rest and think about the silence before lightning. Sometimes, just before a lightning strike very close to you, there is a moment of absolute silence. The birds stop singing. The insects stop buzzing. The wind stops blowing. Everything waits. That silence is caused by the electric field. Some animals and insects sense the field and go quiet. Birds fly to cover. Bees return to their hives. The world holds its breath. And then the lightning comes. Flash, crack, rumble. And then, after the thunder fades, the sounds return. The birds start singing again. The crickets chirp. The wind picks up. The silence is broken, but not in a violent way. It is more like the pause between two notes in a piece of music. A rest, a breath, and then the music continues. That silence is one of the most peaceful parts of a thunderstorm. It is not empty. It is full of anticipation, full of electricity, full of the sky deciding when to release its energy. And in that silence, if you are listening, you can feel your own heartbeat, your own breath. You are part of the waiting, part of the stillness. And then the flash, and then the sound, and then, gradually, the world returns to its normal rhythm. Now, as we continue gently, let us think about lightning and the ionosphere. The ionosphere is the part of the Earth's upper atmosphere, from about 60 to 600 kilometers high, where the sun's radiation knocks electrons off atoms, creating a layer of charged particles. This layer reflects radio waves back to Earth, allowing long-distance communication. Lightning affects the ionosphere. When lightning strikes, it sends up a pulse of electromagnetic energy. That pulse travels to the ionosphere and heats it slightly. It also creates disturbances that can affect GPS signals and radio communications. Scientists study these effects using a technique called very low-frequency radio sounding. They send radio waves up and measure how they come back. The lightning pulse is like a stone dropped into a pond. The ripples spread outward, upward, and bounce off the ionosphere. Those ripples can circle the Earth several times. So every lightning bolt is not just a local event. It is a global event. Its energy spreads across the planet, through the air, through the ground, through space. You cannot see it, but the lightning is talking to the whole world. A whisper that travels around the curve of the Earth. A tiny flash that touches the edge of the sky. Let's take a slow, quiet moment to think about the sound of a single lightning flash from different distances. Imagine a lightning bolt strikes 2 kilometers away. The flash reaches your eyes instantly. 1 second later, you hear a sharp crack. That is the sound from the bottom of the bolt. Then, a moment later, a deeper rumble from the middle. Then a rolling sound from the top. The whole thing lasts maybe 5 or 6 seconds. Now imagine the same bolt 10 kilometers away. The flash is still instant, but the thunder takes 30 seconds to arrive. By then, the sound has spread out. You hear a long, low rumble that lasts 15 seconds. No crack, just a soft, continuous roar. Now imagine the same bolt 100 kilometers away. You see the flash. You wait. Nothing. The sound never reaches you. It has dissipated into the air, turned into heat, lost its energy. So the same lightning bolt sounds completely different depending on where you are. Close, it is a crack. Farther, it is a rumble. Very far, it is silence. And all of these are true. The lightning did not change. Your ears changed. Your distance changed. The air changed. That is a gentle lesson. Perception is not reality. Reality is the lightning. Perception is the story our senses tell us. Both are valid, both are beautiful, and both are temporary. Gently moving forward, let us talk about lightning and the 4th of July. In many countries, the biggest fireworks displays happen during summer. And sometimes a thunderstorm rolls in during the fireworks. Then you see 2 kinds of lights in the sky. The red, green, gold, and blue of the fireworks. And the white, branching light of the lightning. They compete for your attention. The fireworks are loud and close. The thunder is deeper and farther. But eventually the fireworks end. The storm continues. The rain washes the smoke from the air. And you are left with just the lightning. The natural fireworks. The ones that have been happening for billions of years. Long before humans discovered gunpowder. Long before we learned to launch colored balls of light into the air. Lightning is the original fireworks. The first light show. And every time you see it, you are watching a performance that has been playing for the entire history of the planet. No tickets. No schedule. Just the sky, the clouds, and the patient, powerful dance of electrons. That is humbling. And humbling is peaceful. It reminds us that we are small. Not insignificant, but small. And small is safe. Small can rest. Small can let the big things happen without needing to control them. Let us rest and think about lightning in very dry air. In deserts, the air is so dry that rain often evaporates before hitting the ground. But lightning can still happen. Dry lightning is lightning that strikes without rain. It is very dangerous because the lightning can start a fire, and there is no rain to put it out. The fire spreads quickly through dry grass and brush. Whole landscapes can burn. But even dry lightning is just lightning. It follows the same rules. The cloud still has ice crystals. The charge still separates. The stepped leader still reaches down. The only difference is that the air below the cloud is dry. The rain evaporates into nothing. So you see the flash, you hear the thunder, but you never feel a drop. That is strange. Your brain expects rain with lightning. When there is no rain, it feels wrong. But it is not wrong. It is just dry. And the world has many dry places. Many places where water is precious and rare. The lightning does not care. It comes anyway. It brings its heat and its light. And then it leaves. The desert is unchanged. The stones are a little warmer. The air is a little cleaner. And the lightning is gone, moving on to the next cloud, the next storm, the next place where the sky meets the earth. Now, as we continue gently, let us think about lightning in the winter. Most people think of lightning as a summer thing. But lightning can happen in winter too, especially over oceans. When cold air moves over warm ocean water, it creates instability. Warm, moist air rises from the sea, and the cold air above causes it to condense into clouds. These clouds can produce lightning, even when the air temperature is below freezing. This is called thundersnow. Thundersnow is rare and beautiful. You see a flash of lightning, and instead of rain, you hear the soft hiss of falling snow. The thunder is muffled by the snowflakes. It sounds duller, quieter, like someone pounding a pillow. And the lightning itself looks different. The snow reflects the light, making the whole sky glow for an instant. If you are lucky enough to see thundersnow, you will never forget it. It is a reminder that storms can happen in any season, that nature does not follow our calendars. Winter has its own electricity, its own clouds, its own silent, snowy flashes. And if you are inside, warm by a fire, watching thundersnow through a window, it is one of the coziest feelings in the world. The storm is outside. You are inside. The snow falls. The lightning flashes. And you are safe. Let's take a quiet moment to think about the electrical charge of raindrops. Raindrops themselves can carry electrical charge. In a thunderstorm, the raindrops pick up charge from the cloud. Some raindrops are positive, some negative. They fall toward the ground, carrying that charge with them. That creates a current, a very small current, that flows from the cloud to the earth even before the lightning strikes. Scientists measure this current with sensitive instruments. It is called the precipitation current. It is incredibly weak. It would take millions of raindrops to light a small LED. But it is there. It is real. So even the rain is electrical. The whole storm is alive with charge. The ice crystals, the hailstones, the raindrops, the cloud droplets, all of them have tiny electric fields around them. They push and pull on each other. They attract and repel. They are like a crowded room full of people, all carrying invisible magnets. Some attract, some repel. And the lightning is the moment when the pushing and pulling becomes too much, and the whole room empties in one great rush. But before that rush, there is only the gentle, constant movement of charged particles. A soft, invisible dance that you can feel on your skin if you know how to pay attention. Gently moving forward, let us talk about the feeling of lightning in the air. Have you ever been outside just before a thunderstorm and felt your hair stand up? That is not your imagination. Your hair is standing up because the electric field is so strong that it is pulling on the electrons in your body. The same force that makes a balloon stick to the wall after you rub it on your hair. Your hair becomes positively charged, and it repels itself. Each strand tries to get away from the others. So they rise. If you feel your hair standing up during a storm, you are in immediate danger. The lightning is about to strike very close to you. You should crouch down, make yourself as small as possible, and get inside as quickly as you can. But from a safe distance, that feeling is just a curiosity, a reminder that the air is not empty. It is full of forces. You cannot see them, but you can feel them. Your body is a detector. Your hair is an antenna, and the sky is sending you a message that says, something is about to happen, something bright, something loud, something that will change the air for a moment. And then the message fades. The lightning strikes. The field relaxes. and your hair lies back down. The conversation is over. Let us rest and think about the first lightning detector ever invented. Before modern sensors, before radio, before electricity, people used to detect lightning by simply looking and listening. But there was also a device called the lightning bell, invented in the 1700s. It was a simple metal bell connected to a lightning rod. When the electric field became strong, the bell would ring by itself. The charge would jump between the clapper and the bell, making a soft, continuous chime. People used these bells to warn them that a storm was approaching. The sound was not loud. It was like a small, distant wind chime in the wind. But it was enough. Ding, ding, ding. The storm is coming. Take shelter. Later, scientists used more sophisticated detectors. They used gold leaf electroscopes, which are two thin pieces of gold foil hanging side by side. When the electric field is strong, the gold leaves spread apart because they become charged with the same polarity. They repel each other. It is a very quiet visual signal. You watch the leaves slowly separate, like arms opening wide. And you know, the air is charged. The lightning is coming. And you have time. Time to get inside. Time to be safe. Time to watch from a window with a cup of tea as the sky does its work. Now, as we continue gently, let us think about lightning and the speed of sound. We have mentioned that sound is much slower than light, but the exact speed is about 343 meters per second at sea level. That means it takes about 5 seconds for sound to travel 1.7 kilometers. So if you count the seconds between the flash and the thunder, you can estimate how far away the lightning is. 5 seconds equals about 1 mile. 3 seconds equals about 1 kilometer. This is a very old trick. Children learn it in school. But there is something soothing about counting. 1 1,000, 2 1,000, 3 1,000. You are measuring the distance between you and the sky. You are turning a flash of light and a clap of sound into a number. And that number gives you a feeling of control. Not control over the lightning, but control over your understanding. You know where it is. You know it is moving away or coming closer. You can decide what to do. And if the lightning is very far, you can just listen. The thunder becomes a low, soft, distant murmur. Counting becomes pointless because the sound is already a rumble, not a crack. So you stop counting. You just listen. And listening is enough. Let's take a slow, quiet moment to think about the most distant lightning you can hear. The farthest that thunder can be heard is about 25 kilometers under perfect conditions. That is when the air is still and the sound waves do not have to fight against wind. Beyond 25 kilometers, the thunder is too faint for human ears. But sensitive microphones can detect thunder from much farther away, maybe 100 kilometers. And special infrasound detectors, which listen to very low frequencies, can detect thunder from hundreds of kilometers. The infrasound from lightning travels around the world. It is so low that you cannot hear it, but your body might feel it as a subtle pressure change. Some people are sensitive to these changes. They get headaches before a storm. Their joints ache. That is not magic. It is just the body responding to very low-frequency sound waves. Too low to hear, but not too low to feel. So even when the storm is far away, even when the sky is clear, even when you think there is no lightning for 100 kilometers, the earth is still humming with the sound of distant storms. You are surrounded by inaudible thunder, a silent symphony of pressure waves circling the planet. And you are a part of that symphony. Your body resonates with it, quietly, gently, deeply, gently moving forward. Let us talk about lightning in the movies. In films, lightning is often used to create drama. A character has a sudden realization. A monster appears. A storm rages. The lightning flashes at exactly the right moment. But real lightning is not so cooperative. It does not wait for a dramatic pause. It does not strike the tallest building just as the hero looks up. Real lightning is random, unpredictable, and that makes it more interesting, not less. The unpredictability is what gives lightning its soft power. You cannot control it. You can only observe it, only respect it, and there is something very relaxing about that. In a world where we try to control so much, our schedules, our relationships, our health, lightning reminds us that some things are beyond us. And that is okay. We do not have to control everything. We can just watch, just listen, just be present. The lightning will do what it does. It will flash, it will fade, it will return or not, and we can release our need to predict it. We can simply rest in the mystery. That is a very deep kind of peace. The peace of letting go. The peace of saying, I do not need to know. I do not need to be in charge. I just need to be here. Now, watching the sky. Let us rest and think about lightning and the word itself. The word lightning comes from the Old English word leighting, which means to make bright. It is related to the word light. The same root gives us the German word Licht and the Latin word lux. So lightning is literally the act of making light. Not just being light, but making light. The verb form is important. Lightning is something the sky does. It is an action, a process, a becoming. Every time you see lightning, you are watching the sky perform an act of illumination. For a fraction of a second, the sky becomes a light source. Then it stops. The light goes out. The clouds return to darkness. But for that instant, everything is visible. The shape of the clouds, the texture of the rain, the contours of the land. Lightning is a photographic flash from the largest camera in the world. And the photograph is the world itself, printed on your retina. You carry that image with you. You remember it. So lightning is not just an event. It is a memory, a gift, a brief, bright moment that stays with you long after the sky has gone dark again. That is the magic of light. It travels to you, enters your eyes, and changes you. Just a little, just enough. Now, as we continue gently, let us think about lightning and the human brain. The human brain is an electrical organ. Neurons communicate using tiny electrical signals called action potentials. These signals travel along nerve fibers at speeds up to 100 meters per second. That is much slower than lightning, but the principle is similar. An action potential is a wave of charge moving from one place to another. It is like a tiny microscopic lightning bolt inside your head. And when many neurons fire at once, your brain creates electrical fields that can be measured on your scalp. That is what an EEG does. It listens to your brain's electricity. So when you watch a lightning storm, you are using electricity to observe electricity. The lightning in the sky and the lightning in your brain are cousins. They obey the same laws of physics, the same attraction and repulsion, the same need for balance. And when you fall asleep, your brain's electrical activity slows down. The neurons fire less often. The waves become longer and deeper. You enter a state called slow-wave sleep. And in that state, you are like a quiet thunderstorm. Not flashing, not rumbling, just resting. Storing energy for the next day. Waiting. Patiently. Peacefully. Let's take a quiet moment to think about lightning and the heart. The human heart also runs on electricity. Every heartbeat begins with an electrical signal in the sinoatrial node, a small cluster of cells in the right atrium. That signal spreads through the heart, causing the muscles to contract in a coordinated way. An electrocardiogram, or ECG, measures that electrical activity. It looks like a series of spikes and waves. A healthy heart has a steady rhythm. An unhealthy heart might have extra beats, skipped beats, or chaotic rhythms called arrhythmias. Lightning can affect the heart. A lightning strike can stop the heart by overwhelming its natural electrical system. That is why CPR is so important. The chest compressions keep the blood flowing until the heart can restart on its own. But lightning can also restart a stopped heart. No, that is a myth. Defibrillators restart hearts, not lightning. Lightning is too powerful. It is like trying to fix a watch with a hammer. So we do not want lightning near our hearts. But we can still appreciate that both lightning and hearts are electrical. Both have rhythms. Both can be steady or chaotic. And both, in their own way, are signs of life. The sky's heart beats with lightning. The earth's heart beats with thunder. And your heart beats with you, right now in this quiet room. Bottom, bottom, bottom. A steady, gentle drum. Gently moving forward. Let us talk about lightning and the sense of smell we mentioned earlier. Ozone is not the only smell after a storm. There is also the smell of wet earth, which is petrichor. Petrichor comes from oils released by plants and bacteria in the soil. When rain falls on dry ground, it kicks these oils into the air, and we smell them. There is also the smell of wet concrete, wet asphalt, wet leaves. Each has its own chemistry. But ozone is the purest, cleanest smell. It smells like the air after a lightning strike. Sharp, bright, almost metallic. Some people love it. Others find it slightly unpleasant. But it is unmistakable. If you smell ozone, you know lightning has been very close, very recently. And that knowledge changes how you feel. You become alert. Your nostrils flare. Your brain says something powerful just happened here. Then, after a few minutes, the ozone breaks down. The smell fades. The air returns to normal. Your brain relaxes. You go back to breathing without thinking. In and out. In and out. The storm is past. The electricity is gone. And the world smells fresh, clean, new. Like the first morning after a long night. Let us rest and think about the first photograph of lightning. The first successful photograph of lightning was taken in 1882 by a photographer named William Jennings. He used a large, heavy camera on a tripod. He opened the shutter and waited. The lightning flashed. The shutter closed. And when he developed the plate, there it was. A branching, jagged bolt against a dark sky. It was the first time anyone had captured lightning in a permanent image. Before that, lightning existed only in memory and in drawings. But photography changed that. Now we could study lightning. We could compare one bolt to another. We could measure their shapes, their lengths, their brightness. And we could share them. People who had never seen lightning could see it in a book or a magazine. That was revolutionary. Today, we take photographs of lightning with our phones. We post them online. We see lightning from all over the world, from all kinds of storms, all kinds of landscapes. And each photograph is a frozen moment, a pause in the sky's dance, a small, silent gift from the past to the present. The lightning is long gone, but the light remains. In the photograph, in your eyes, in your quiet, resting mind. Now, as we continue gently, let us think about lightning and time-lapse photography. Time-lapse is a technique where you take many photos over a long period and then play them back quickly. A thunderstorm that lasts an hour can be compressed into 10 seconds. In a time-lapse, you see the clouds boiling, growing, rising. You see the lightning flashing again and again, like a strobe light. And you see the storm move across the landscape, darkening the ground, then passing, then leaving behind a clear sky. Time-lapse reveals the patterns that are too slow for our eyes to see. It shows that storms are not chaotic. They have shapes. They have rhythms. They are like living things breathing and moving. And when you watch a time-lapse of lightning, you feel the slow, deep pulse of the atmosphere. The way it cycles. The way it rests. The way it builds up energy and then releases it. That is very much like sleep. Sleep also has cycles. Light sleep, deep sleep, REM sleep. They cycle every 90 minutes. And over the course of a night, you move through these cycles, building and releasing, building and releasing. So watch a time-lapse of a thunderstorm as you fall asleep. Let your breathing match the rhythm of the clouds. In, out, flash, rest, in, out, flash, rest. Let's take a slow, quiet moment to think about lightning and the color of thunder. Thunder does not have a color, of course, but we often say that thunder is a deep, low sound. And deep, low sounds feel like the color dark blue or dark purple. High sounds feel like bright yellow or white. So when we hear a rumble, we might imagine a dark, rolling color. When we hear a crack, we might imagine a sharp, bright color. This is called synesthesia, the mixing of senses. Some people naturally see colors when they hear sounds. For them, thunder might be a deep indigo and lightning a brilliant white. But even if you do not have synesthesia, you can imagine it. Close your eyes. Listen to the thunder. What color is it? Is it blue? Gray? Black? There is no wrong answer. Your mind is free to paint the sound. And the sound is free to paint your mind. That is the beauty of perception. You are not just a passive receiver. You are an active creator. You take the raw sensations, the light, the sound, the smell, and you build a world inside your head. A world where thunder has color and lightning has texture. A world where you are safe and warm and drifting. A world of your own making. Gently moving forward, let us talk about lightning and the placebo effect. The placebo effect is when a person feels better because they believe they are receiving treatment, even if the treatment is fake. It is a real effect caused by the brain releasing natural painkillers and other chemicals. But what does that have to do with lightning? Well, some people believe that lightning has healing properties. In ancient times, people thought that lightning-struck stones, called thunderstones, could cure diseases or protect against evil spirits. They carried them as amulets. Even today, some people believe that being struck by lightning can cure illnesses or give special powers. This is not true. Lightning does not heal. It hurts, but the belief in its power can have a placebo effect. If you believe a thunderstone will protect you, you might feel less anxious. And less anxiety is good for your health. So in a roundabout way, the belief in lightning's healing power can actually heal a little bit through the power of your own mind. That is not magic. That is biology. Your brain is a powerful organ. It can change your body just by changing your thoughts. So think gentle thoughts about lightning. Think of it as beautiful, not scary. And your body will relax. Your heart will slow. Your breath will deepen. And you will drift closer to sleep. Let us rest and think about lightning and the number of times you have seen it in your life. If you are an average person, you have seen lightning hundreds of times, maybe thousands. Each time was different. Each flash had its own shape, its own brightness, its own distance. Some flashes were close, making you jump. Others were far, just a soft glow on the horizon. Some were quick, single strokes. Others were long, flickering multiple times. And you will see lightning again. Next summer. Next storm. Next time you look out the window at night and see the sky light up. That is a comforting thought. Lightning is not going away. It has been here for billions of years. It will be here for billions more. It is part of the Earth's story. And you are part of that story too, but only for a short time. A tiny, precious moment in the long history of the planet. So when you see lightning, you are not just watching a natural phenomenon. You are witnessing something that has been happening since before there were eyes to see it. And you are lucky. Lucky to have eyes. Lucky to have a storm. Lucky to be alive right now in this quiet moment, thinking about electricity and clouds and the soft rumble of distant thunder. Now, as we continue gently, let us think about lightning and the concept of grounding. In electricity, grounding means connecting a circuit to the earth, so that excess charge can flow away harmlessly. That is what a lightning rod does. It grounds the building. In human psychology, grounding means connecting with the present moment, often by focusing on your body or your surroundings. For example, you might notice your feet on the floor, the weight of your body on the chair, the sound of your breathing. That is grounding. And interestingly, watching lightning can be a grounding experience. You look at the sky, you see the flash, you hear the rumble, you feel the air on your skin. You are here, now, in the world, not lost in thought, not worrying about tomorrow, just present. Present with the storm, present with yourself, and that presence is very peaceful. It is like a lightning rod for your mind. The charge of your anxious thoughts flows down into the earth, into the present moment, and dissipates. You are safe. You are grounded. You are exactly where you need to be. So let the lightning be your teacher. Let it show you how to be here, now, without rushing, without fearing, without needing anything other than this soft, simple awareness. Let's take a quiet moment to think about the end of a thunderstorm. Every storm ends. The rain slows. The thunder grows softer, more distant. The lightning flashes less often. Then finally there is a long pause. You wait. No flash. You wait another minute. Still no flash. Then another. The storm has moved on. The sky begins to clear. Perhaps a patch of blue appears. Perhaps the moon or the stars come out. The air feels washed, clean, cool. You take a deep breath. The world is quiet. The birds start singing again. The dogs stop barking. The wind settles into a gentle breeze. And you feel a sense of relief. Not because you were afraid, but because the tension is gone. The electric field has relaxed. The air is neutral again. The storm has done its work. It has watered the ground. It has fertilized the soil. It has cleared the air. And now it is leaving. Just as every storm leaves. Just as every difficult moment passes. Just as every night gives way to morning. The ending of a storm is a promise. A promise that no matter how dark the sky gets, the light will return. Not the lightning light, but the soft, steady light of day, or the gentle, silver light of the moon, or the tiny, twinkling light of the stars. All of them waiting for the storm to pass. All of them patient. All of them calm, gently moving forward. Let us talk about lightning and the sense of hearing protection. If you are very close to a lightning strike, the thunder can be loud enough to damage your hearing. A crack of close thunder can reach 120 decibels, which is as loud as a jackhammer or a rock concert. Prolonged exposure to sounds that loud can cause permanent hearing loss. But you are not going to stand next to a lightning strike. You are inside, safe, listening from a distance. The thunder you hear is much softer, maybe 60 or 70 decibels, which is like a normal conversation. So your ears are safe. You can listen without worry. And yet, it is interesting to think about how loud thunder can be. The loudest thunder ever recorded was probably from a lightning strike very close to a microphone. It might have reached 150 decibels, which is enough to cause physical pain. But again, you are not there. You are here, in a quiet room, with soft blankets and a soft voice. The thunder outside is a whisper. A gentle giant speaking in a low, kind voice. And you can listen as long as you like, until the thunder fades, until your eyes close, until the only sound is your own breathing. Slow, soft, safe. Let us rest and think about lightning in different languages around the world. In Spanish, lightning is relámpago. In French, éclair. In German, blitz. In Italian, fulmen. In Japanese, inazuma. In Chinese, shandian. In Hindi, bijli. Each word has a slightly different feeling. Relámpago sounds fast and sharp. Éclair is also the word for a cream puff, which is a funny connection. Blitz sounds strong and aggressive. Fulmen sounds heavy and dramatic. Inazuma sounds beautiful, almost poetic. And shandian means flash of electricity. The variety of words reminds us that lightning is a global phenomenon. Every language has a word for it because every culture has experienced it. Every culture has looked up at the sky and seen that bright, branching light. And every culture has found a way to name it, to talk about it, to tell stories about it. So when you see lightning, You are sharing an experience with every human who has ever lived. All the way back to the first people who saw lightning and wondered what it was. That is a very large, very old, very quiet connection. A thread of light that ties all of us together across time and space. Now, as we continue gently, let us think about lightning and the moment of impact. When lightning strikes the ground, it can do strange things. It can melt sand into glass, as we talked about with fulgurites. It can explode trees, sending splinters flying. It can fuse metal objects together. It can create a crater in soft soil. It can even turn a person's clothes into ash without burning their skin. That last one is because of the flashover effect. The lightning goes around the body, heating the clothes so fast that they vaporize. The person is unharmed but naked. These stories seem dramatic, but they are just physics. Extreme heat, extreme speed, extreme power. And yet, after the lightning passes, everything is still. The glass cools. The tree lies on the ground. The metal is welded. The crater is a small hollow. The person stands in shock but alive. The lightning does not linger. It does not gloat. It does not hold a grudge. It comes, it does its work, and it leaves. Like a passing thought. Like a shooting star, like a moment of clarity that arrives, changes you, and disappears before you can fully grasp it. That is lightning, brief, powerful, and then gone, leaving only the memory of light. Let's take a slow, quiet moment to think about lightning and the fear of it. Many people are afraid of lightning. That is natural. It is loud, bright, unpredictable, and dangerous. But fear can be softened by understanding. When you know how lightning works, it becomes less mysterious. Less like a monster and more like a machine. A beautiful, powerful machine, but a machine nonetheless. It follows rules. It is predictable in its unpredictability. And you can protect yourself from it with simple, easy steps. Go inside. Stay away from windows. Don't use corded electronics. Don't take a shower or a bath. Wait 30 minutes after the last thunder. That is all. Those small actions turn fear into safety. And safety is calm. So if you are afraid of lightning, let this video be a gentle medicine. Let each fact soften that fear a little more. Let the soft voice, the slow pace, the quiet repetition wash over you. The lightning is outside. You are inside. The lightning does not want to hurt you. It does not even know you exist. It is just doing what lightning does. And you are just doing what you do. Resting, breathing, letting go. One breath at a time. One fact at a time. One soft, sleepy moment after another. Gently moving forward, let us talk about lightning and the concept of entropy. Entropy is a measure of disorder or randomness. In any closed system, entropy tends to increase over time. That is the second law of thermodynamics. Lightning seems like it would increase entropy. It scrambles things. It melts sand, explodes trees, creates chaos. But actually, lightning also creates order. It separates charge in the cloud. That separation is a form of order. A negative bottom and a positive top. That is not random. That is structured. So lightning is both order and disorder. It creates a pattern of charge, then discharges it. It builds up, then breaks down. That cycle is very similar to the cycle of life. We build up energy during the day. We release it during sleep. We build up again. We release again. Entropy increases over the long term, but in the short term, there are local decreases. Pockets of order in the sea of chaos. Lightning is one of those pockets. A brief, bright order. A flash of structure in the random dance of molecules. And your brain is another pocket of order. Billions of neurons firing in patterns that create thoughts, feelings, memories. And when you sleep, that order dissolves into something else. Not chaos, but a different kind of order. A slower rhythm. A deeper quiet. A gentle, dreamy rest. Let us rest and think about the lightning capital of the United States. That is Florida. specifically the area between Tampa and Orlando. Florida gets more lightning than any other state because it is a peninsula surrounded by warm water. The sun heats the land during the day, and the warm, moist air rises. The sea breezes from both coasts collide in the middle, forcing the air even higher. Thunderstorms form almost every afternoon in the summer, and with them, lightning. Lots of lightning. If you live in Florida, you learn to respect the storms. You know that after 2 p.m., the sky will darken, the wind will pick up, and the lightning will start. You plan your outdoor activities for the morning. You watch the radar on your phone. You listen for thunder. And when the storm comes, you wait. Maybe 20 minutes. Maybe an hour. Then the sun comes out again. The steam rises from the asphalt. The air smells like ozone and rain. And you go back outside. That is the rhythm of Florida. Storm, sun, storm, sun. It is like a heartbeat, a pulse, a reminder that the sky is alive and active, even in the flat, hot, humid lowlands. So if you ever visit Florida, bring an umbrella and a healthy respect for the flashing sky. Now, as we continue gently, let us think about lightning in the Great Plains of North America. The Great Plains are known for severe thunderstorms, especially in the spring and early summer. The flat land allows storms to grow very tall. There is nothing to block the wind or break the updrafts. These storms can produce huge hailstones, damaging winds, and tornadoes. But they also produce incredible lightning displays. The lightning is often cloud to ground, with many strokes per flash. The thunder echoes across the plains for miles. There is no mountain to reflect it, so the sound just rolls and rolls, fading slowly into the distance. On a clear night, you can see a thunderstorm from 100 kilometers away. The lightning lights up the entire sky, reflecting off the flat horizon. It is like watching a distant battle, but the battle is just physics. Warm air meeting cool air, ice crystals colliding, electrons jumping, and you, sitting on your porch wrapped in a blanket, watching the show. The storm may never reach you. It might stay on the horizon for hours, flickering, rumbling, moving slowly east or north. And you can watch it until your eyes get heavy, until the lightning becomes a soft, rhythmic pulse, until you decide it is time to go inside, to close the curtains, to lie down, and to let the sound of distant thunder carry you into sleep. Let's take a quiet moment to think about lightning in the Australian outback. Australia has some of the most spectacular lightning storms in the world, especially in the northern tropics during the wet season. The storms there are called the buildup. The air is thick with humidity. The clouds pile up like mountains, and the lightning flashes almost continuously, sometimes hundreds of times per hour. The Aboriginal people of Australia have many stories about lightning. They see it as a powerful spirit, a creator and a destroyer. They have lived with lightning for tens of thousands of years. They know where to shelter. They know when to stay inside. And they also know the beauty of it. The way the lightning reflects off the red rocks. The way the thunder shakes the dry earth. The way the rain follows, turning dry riverbeds into rushing torrents. In the outback, lightning is life. It brings water. It brings green growth. It brings kangaroos and emus to the new grass. So the lightning is welcomed, even feared a little, but always respected. And when the storm passes, the sky clears, and the stars come out. Millions of stars, because there is no city light to hide them. And among those stars, sometimes you can see a faint, distant flash. Another storm over the horizon. Another pulse of electricity. Another reminder that the sky is never truly quiet. It is always talking, always flashing, always whispering, gently moving forward. Let us talk about lightning and the concept of resonance. Resonance happens when something vibrates at its natural frequency. For example, a wine glass will shatter if you sing a note at the right pitch. The glass resonates. The sound waves match its natural vibration, and it breaks. Thunder can create resonance too. In a valley or a canyon, the thunder echoes back and forth, bouncing off the walls. The echoes overlap, creating a sustained, rumbling sound that can last for many seconds. That is acoustic resonance. The shape of the land determines how the thunder sounds. In a narrow canyon, thunder is sharp and quick. In a wide valley, it is long and low. In a forest, it is muffled by the trees. In a city, it is scattered by the buildings. So each thunderstorm sounds different depending on where it happens. The same lightning, the same thunder, but the landscape paints it with its own colors. That is another way that lightning is connected to the earth. The earth does not just receive the lightning. It shapes the sound. It sings along. And if you listen carefully, you can hear the voice of the land in the thunder. The mountains, the valleys, the forests, the cities. All of them adding their own notes to the sky's song. Let us rest and think about lightning and the concept of capacitance. A capacitor is a device that stores electrical energy. It has two conductors separated by an insulator. A thunderstorm is like a giant capacitor. The cloud is one conductor. The ground is the other. The air is the insulator. When the charge builds up, the capacitor stores energy. When the lightning strikes, the capacitor discharges. That is exactly how an electronic capacitor works, just on a much larger scale. So every thunderstorm is a natural capacitor, a battery made of clouds and earth. And the lightning is the short circuit that drains the battery. That is a very simple, elegant way to think about it. No mystery, no magic, just a giant, natural electrical component. And capacitors are used in almost every electronic device. Your phone has capacitors. Your computer has capacitors. Your television has capacitors. So in a way, your phone is a tiny thunderstorm. It stores charge. It discharges. It flashes. Not with visible light, but with the invisible light of computation. That is a nice thought. The same physics that lights up the sky also lights up your screen. The same electrons. The same rules. The same quiet, reliable behavior. So when you hold your phone, you are holding a piece of a thunderstorm. A tiny, tame, domesticated lightning bolt. Now, as we continue gently, let us think about lightning and the concept of breakdown voltage. Breakdown voltage is the voltage at which an insulator stops insulating and becomes a conductor. For dry air at sea level, the breakdown voltage is about 3 million volts per meter. That means if you have two metal plates 1 meter apart, and you apply 3 million volts between them, the air will break down and a spark will jump across. For lightning, the distance is several kilometers, so the voltage needed is billions of volts. And the air is not dry. It has water droplets, ice crystals, dust, pollution. All of those things lower the breakdown voltage slightly. So lightning happens when the electric field reaches about 1 million volts per meter over a large volume of air. That is the threshold, the tipping point, the moment when the air gives up and says, "Fine, I will conduct." And once that threshold is crossed, the lightning happens very quickly. But the buildup is slow. The cloud charges for minutes, sometimes hours. It approaches the threshold gradually. Then, at the right moment, it crosses. That is very much like falling asleep. You do not just fall asleep instantly. You drift. Your brain waves slow down. Your muscles relax. Your thoughts become softer, less connected. You approach the threshold. And then gently you cross. The moment of sleep is like the moment of breakdown. The insulator becomes a conductor. The conscious mind becomes the dreaming mind. A soft, quiet flash. Let's take a slow, quiet moment to think about lightning and the color of the flash at different times of day. During the day, lightning looks white or blue-white. The bright flash overwhelms your color vision. Your cones, the color-sensing cells in your eyes, are saturated. They cannot tell what color the light is, so you see white. At twilight, the sky is darker, and your eyes are more sensitive. The lightning might look pale blue or lavender. At night, if your eyes are dark adapted, you can see the true color of the lightning. Often it is a warm pink or orange, especially if there is dust or pollution in the air. Sometimes it is a deep purple. Rarely, it is green or red. And if you are very lucky, you might see a blue jet or a red sprite. Those are colors you will never forget. Bright, electric blue. Deep cherry red. But even ordinary lightning on an ordinary night has color. You just have to look. Not stare, not strain, just look softly. Let your eyes rest. Let the light touch your retina. And see what color it is. It might be different every time. That is part of the beauty. The lightning is never exactly the same. The colors shift. The shapes shift. The sounds shift. And you are there, watching, resting, being a quiet witness to the sky's endless variety. Gently moving forward, let us talk about lightning and the concept of current. Current is the flow of electric charge. It is measured in amperes, or amps. A typical lightning bolt carries about 30,000 amps. That is huge compared to household current, which is 15 or 20 amps. But some lightning bolts carry much more, up to 300,000 amps. Those are the positive lightning bolts we talked about. They are the heavy lifters, the superstars. But even a small lightning bolt carries more current than anything you will ever encounter in daily life. That is why lightning is dangerous. It is not the voltage that kills you, it is the current. Voltage is the pressure. Current is the flow. A static electricity spark might have 10,000 volts, but only a tiny fraction of an amp. It stings but does not kill. Lightning has billions of volts and tens of thousands of amps. That is lethal. But again, you are not going to be near it. You are inside. You are safe. You are just learning. And learning is relaxing. It gives your mind something to do while your body rests. Something gentle. Something interesting. Something that does not demand action, only attention. Soft, quiet, sleepy attention. The kind of attention you give to a candle flame, or to the sound of rain, or to the slow, steady voice in your ears, telling you about the sky. Let us rest and think about lightning and the concept of resistance. Resistance is a measure of how hard it is for electricity to flow through a material. Air has very high resistance. That is why lightning has to work so hard to break through. Metal has very low resistance. That is why lightning rods work. The electricity prefers the low resistance path. Water has medium resistance, depending on how pure it is. Pure water is actually an insulator, but rainwater is not pure. It has dissolved salts and minerals, which make it conductive. That is why puddles can conduct lightning current. That is also why you should not stand in water during a storm. Resistance is also why lightning sometimes follows the same path multiple times. Once the air is ionized, its resistance drops dramatically. So subsequent strokes take the easy path. They follow the old channel. That is why lightning flickers. The first stroke creates the path. The next strokes just follow. Like walking through fresh snow. The first person breaks the trail. Everyone after that has an easier time. So the leader is the first stroke. The subsequent strokes are the followers. And all of them together make the lightning we see. A team of electrical explorers, working together to bring balance to the sky. Now, as we continue gently, let us think about lightning and the concept of power. Power is the rate at which energy is used. It is measured in watts. A typical lightning bolt has a peak power of about 1 trillion watts. That is 1 trillion watts. For comparison, a large nuclear power plant produces about 1 billion watts. So a lightning bolt is 1,000 times more powerful than a nuclear power plant, but only for a tiny fraction of a second. The total energy in a lightning bolt is about 500 megajoules, which is about the same as the energy in 20 liters of gasoline. So lightning is not actually that energetic. It is just very concentrated in time and space. That is why you can survive a lightning strike. The total energy is not enormous. It is the power that is enormous. The power is what causes the damage. The sudden, intense heat. The explosive expansion of air. The shockwave. So when you see lightning, you are seeing 1,000,000,000 watts of power concentrated into a thin tube of plasma, lasting for a few millionths of a second. That is an astonishing number, but it is also just a number. You do not need to remember it. You can just let it float by like a cloud, a big, impressive cloud, and then it is gone, and you are still here, still breathing, still safe, still drifting. Let's take a quiet moment to think about lightning and the concept of frequency. The frequency of lightning is how often it happens. We already talked about the global average, about 50 to 100 flashes per second. But the frequency varies a lot by location. In the Congo Basin in Africa, there are thunderstorms almost every day of the year. The frequency there is very high. In the Arctic, it is almost zero, and the frequency also varies by season. Summer has more lightning than winter. Afternoon has more lightning than morning. There is also a daily cycle. Over land, lightning peaks in the late afternoon, when the sun has heated the ground the most. Over the ocean, lightning peaks in the early morning, when the air is most unstable. So the earth has a rhythm, a daily heartbeat of lightning. Thump in the afternoon over the continents. Thump in the early morning over the seas. And if you could see all the lightning in the world at once, you would see the pattern. A wave of flashes moving around the planet. A soft, pulsing glow. Like a giant, sleeping animal breathing in its sleep. And you are part of that animal. You live on its skin. You breathe its air. You watch its lightning. And then you sleep as the animal sleeps, as the flashes continue, as the sky does its work, whether you are watching or not. Gently moving forward, let us talk about lightning and the concept of wavelength. Light has wavelength. The color we see depends on the wavelength. Blue light has short wavelength. Red light has long wavelength. Lightning produces light across the entire visible spectrum, which is why it looks white. But it also produces light outside the visible spectrum. Ultraviolet light, which can give you a sunburn. And infrared light, which is heat. And radio waves, which are very long wavelength light. That radio wave energy is what we use to detect lightning from far away. So lightning is a broad-spectrum light source. It is like a tiny sun for a tiny fraction of a second. It produces every kind of electromagnetic wave, from gamma rays to radio waves. Yes, gamma rays. Scientists have detected gamma rays from lightning. They are called terrestrial gamma ray flashes. They are very brief, very energetic bursts of radiation. They were discovered by accident in the 1990s by satellites looking for gamma rays from space. And they are still a mystery. No one knows exactly how lightning produces gamma rays. But it does. So lightning is even more amazing than we thought. It is not just visible light, sound, and radio. It is also X-rays and gamma rays. The sky is a particle accelerator, and you are lying under it, safe and warm, learning about its secrets, one soft fact at a time. Let us rest and think about the first time you ever saw lightning. You probably do not remember. You were very young. Maybe a baby. Maybe a toddler. You were in a car, or in a house, or in someone's arms. There was a flash. Your parents said, "Look, lightning." And you looked. You saw the bright light. You might have been frightened or curious or just sleepy. That first lightning was the beginning of a lifelong relationship. A relationship with the sky, with the weather, with the electric force that shapes our world. And now, all these years later, you are here listening to a soft voice, learning about that same lightning. The lightning has not changed. It still flashes. It still rumbles. It still makes ozone and fertilizer in glass. But you have changed. You have grown. You have learned. And now you understand a little more. Not everything, but enough. Enough to respect it. Enough to be safe. Enough to find peace in its presence. So thank that first lightning. Thank the storm that introduced you to this beautiful, powerful, gentle phenomenon. And thank yourself for being curious, for being open, for being here, now in this quiet moment, ready to rest. Now, as we continue gently, let us think about lightning and the concept of memory. We have memories of storms. We remember where we were, who we were with, how we felt. Those memories are stored in our brains as patterns of synaptic connections. Every time we recall a memory, we strengthen those connections. So the more you think about lightning, the more you remember about lightning. And the more you remember, the more familiar it becomes. Familiarity breeds calm. When something is familiar, you are not afraid. You are just comfortable. So by learning about lightning, by hearing these facts, by letting them sink in slowly, you are building a map of familiarity. A map that says, I know this. I understand this. This is not a threat. It is just the sky doing its thing. And that map will stay with you. The next time you see a storm, you will remember. You will remember the stepped leader and the upward streamer. You will remember the ozone smell and the rumbling thunder. You will remember that lightning is patient, gentle, and natural. And you will feel calm. Not excited, not scared, just calm. Calm like the air after a storm. Calm like a sleeping child. Calm like you, right now, as you listen to these words, as your eyes grow heavy, as your breath slows, as you let go of everything except this moment. Let's take a slow, quiet moment to think about lightning and the concept of endings. Every lightning flash ends. Every thunderclap fades. Every storm passes. Endings are natural. They are not sad. They are just transitions. The lightning ends, but the energy that was in the lightning does not disappear. It turns into heat, into light, into sound, into radio waves, into chemical changes in the air. The energy is conserved. It simply changes form. So nothing really ends. It just becomes something else. That is the first law of thermodynamics. Energy cannot be created or destroyed, only transformed. So the lightning bolt that flashed 1,000 years ago is still here. Its energy is in the air, in the soil, in the plants, in the animals. It is in you. You are made of atoms that have been around since the Big Bang. Those atoms have been in stars, in oceans, in dinosaurs, in lightning bolts. And now they are in you. And one day they will be in something else. A tree, a cloud, a bird, another lightning bolt. So do not worry about endings. There are no endings, only changes. Soft, slow, beautiful changes. Like the change from waking to sleeping. Like the change from a bright flash to a dark sky. Like the change from a storm to a calm, clear night. Gently moving forward, let us talk about lightning and the concept of stillness. After a storm, the world is very still. The wind has stopped. The birds are quiet. The air is cool and clean. That stillness is precious. It is the silence after the music, the rest after the exercise, the sleep after the day. And stillness is where we find peace. Not in action, not in motion, but in rest. In the absence of movement. In the quiet hum of the earth. So let the lightning and thunder be the music that leads you to stillness. Let them play their loud, bright notes, and then let them fade. And in the fading, find your rest. Your body knows how to rest. It has been resting every night of your life. It knows the way. You do not have to teach it. You just have to get out of the way. Stop trying. Stop thinking. Stop holding on. Just let go. Let the stillness rise up from your bones, from your muscles, from your breath. Let it fill you like water filling a cup. And when you are full of stillness, you will sleep. Deeply, quietly, without dreams or with gentle dreams, or with no memory of dreams at all. Just the soft, dark, peaceful rest that every living thing needs. Let us rest and think about lightning and the concept of time. Lightning happens in milliseconds. Thunder takes seconds. A storm lasts hours. The season lasts months. The climate patterns last years. The Earth's geological history lasts billions of years, and the universe lasts forever, as far as we know. So lightning happens on many different time scales. The flash itself is almost instantaneous. The rumble stretches out. The memory of the storm lingers. And the effects of the lightning, the nitrogen fixation, the fulgurites, the burned trees, last for years or centuries. So lightning is a bridge between the shortest and longest time scales. It is a moment that echoes. It is a flash that leaves a mark. That is why lightning feels so significant. It connects the instant to the eternal, the tiny to the vast. And you are also a bridge. Your life is a flash in the history of the planet. A brief, bright moment. But your actions, your words, your memories, they echo. They leave marks. They change the world in small ways. So be kind to yourself. Be gentle. You are a lightning bolt in the dark. Brief but beautiful. And then you rest. And then you are gone. And that is okay. That is more than okay. That is perfect. Now, as we continue gently, let us think about lightning and the concept of probability. The chance that any specific person will be struck by lightning in their lifetime is about 1 in 15,000. That is very low. Lower than the chance of being in a car accident, or dying from the flu, or getting attacked by a dog. So you do not need to worry about lightning. It is a rare event. Even if you live in Florida, even if you spend a lot of time outdoors, the odds are still in your favor. But probability is not destiny. Some people are struck multiple times. There is a man named Roy Sullivan, a park ranger in Virginia, who was struck by lightning 7 times. He survived every time. That is extremely unlikely, but it happened. So probability is just a number. It describes groups, not individuals. For you, right now, in this safe place, the probability of being struck is 0. Because you are inside. You are not in a field. You are not under a tree. You are listening to a soft voice and resting your eyes. So let probability comfort you. The lightning is not coming for you. It is not hiding around the corner. It is far away, or it is not there at all. And even if it were, you are safe. So relax. Let the numbers drift away. You do not need them. Let's take a quiet moment to think about lightning and the concept of awe. Awe is the feeling we get when we encounter something vast, powerful, and beautiful. Something that transcends our everyday experience. Lightning inspires awe. So do mountains, oceans, forests, starry skies. Awe is a positive emotion. It makes us feel small, but in a good way. Small and connected. Part of something larger than ourselves. That feeling is relaxing. It takes the pressure off. You do not have to be the center of the universe. You do not have to control everything. You can just be a witness. A witness to the awesome, beautiful, terrifying, wonderful world. And awe has been shown to reduce stress, improve mood, and increase feelings of well-being. So when you watch lightning, let yourself feel awe. Not fear, not anxiety, just awe. Let your mouth fall open slightly. Let your eyes widen. Let your breath catch. And then release. Awe is like a gentle stretching of the soul. It opens you up. It reminds you that there is more to life than your problems, your worries, your to-do lists. There is also the sky. There is also the lightning. There is also this moment, right now, where you are safe and small and full of wonder. Gently moving forward, let us talk about lightning and the concept of beauty. Beauty is subjective. Some people think lightning is beautiful. Others think it is scary. But most people, if they are honest, find something beautiful in a lightning storm. The contrast of light and dark. The jagged, branching shape. The way the whole sky lights up for an instant. And there is a scientific reason why we find certain patterns beautiful. Our brains are wired to notice edges, contrasts, and fractal patterns. Lightning is a fractal. It looks the same at different scales. The main bolt branches into smaller bolts, which branch into even smaller bolts. That self-similarity is pleasing to the brain. It is the same pattern we see in trees, in rivers, in blood vessels, in coastlines. So when you see lightning, your brain says, "Ah, I know this pattern. This is a pattern I have seen before. This is a pattern that means life, growth, movement." And that recognition feels good. It feels right. So lightning is beautiful not just because of the light, but because of the shape of life, the shape of nature, the shape of the world drawn in fire across the sky. Let us rest and think about lightning and the concept of gratitude. Gratitude is a quiet, gentle emotion. It is the feeling of appreciation for what you have. And you can feel gratitude for lightning. You can be grateful that lightning exists because it makes the air cleaner, the soil richer, and the world more interesting. You can be grateful that you are safe from lightning because you are inside, or because the storm is far away. You can be grateful for the light show, for the sound, for the smell. You can be grateful for the scientists who studied lightning and taught us how to protect ourselves. You can be grateful for your eyes, which can see the flash, for your ears, which can hear the rumble, for your nose, which can smell the ozone, for your skin, which can feel the cool breeze after the storm. Gratitude is a very sleepy emotion. It softens the heart. It slows the breath. It opens the door to rest. So as you listen to the last of these facts, let gratitude fill you. Thank the lightning. Thank the sky. Thank the earth. Thank yourself for being here, for listening, for resting. And then let the gratitude fade into something even softer. Contentment, peace, sleep. Now, as we continue gently, let us think about lightning and the concept of mystery. Even after all these facts, there is still mystery. We do not know exactly how lightning starts. We do not know exactly how ball lightning works. We do not know exactly why some lightning produces gamma rays. We have theories, but not proofs. The mystery is part of the beauty. If we knew everything, the sky would be smaller, less magical. But the sky is not small. It is vast and deep and full of secrets. And that is wonderful, because mystery invites curiosity, and curiosity invites learning, and learning invites wonder, and wonder invites peace. So do not be frustrated by the mystery. Embrace it. Let it be the soft, dark background against which the bright facts shine. You do not have to solve everything. You do not have to understand everything. You can simply rest in the not knowing. Rest in the questions. Rest in the uncertainty. That is a very advanced form of peace. The peace of surrender. The peace of saying, I do not know, and I am okay with that. I am okay with the mystery. I am okay with the lightning. I am okay with being small and curious and sleepy. So very sleepy. Let's take a slow, quiet moment to think about lightning and the concept of silence. After a long thunderstorm, when the last flash has faded and the last rumble has died away, there is silence. A deep, profound silence. The silence of the world catching its breath. And in that silence, you can hear yourself, your heartbeat, your breathing, the tiny sounds of your body, the creak of the house settling, the hum of the refrigerator, the whisper of the wind outside. That silence is not empty. It is full of small, quiet sounds. The sounds of life continuing. The sounds of the ordinary world, returning after the drama of the storm. And silence is the best friend of sleep. Sleep comes from silence. Sleep lives in silence. So when the storm ends, when the lightning is gone, when the thunder is just a memory, welcome the silence. Let it wrap around you like a soft blanket. Let it fill your ears, your mind, your heart. Let it carry you down, down, down into the deep, dark, quiet place where you rest and heal and dream. There is no need to hold on to anything. The lightning is gone. The facts are almost done. Only silence remains. And silence is enough. Gently moving forward, let us think about the final moments of a lightning storm. The storm is moving away. The lightning is now just a soft glow on the horizon, like heat lightning. The thunder is a low, continuous murmur, like a bowling ball rolling down a long, carpeted hallway. The rain has stopped or turned to a light drizzle. The clouds are breaking open. You see patches of blue or a few stars. The air is cool and fresh. You take a deep breath. You feel the tiredness in your body, the weight of your eyelids, the soft pull of gravity. Everything is telling you to rest. So rest. The storm is over. The danger is gone. The learning is done. You have spent hours listening, thinking, drifting. You have earned your sleep. So let go. Let your head sink into the pillow. Let your hands relax. Let your jaw unclench. Let your eyes close. There is nothing more to do. Nothing more to learn. Nothing more to fear. Just the soft, steady rhythm of your breath. In and out. In and out. And somewhere far away, a final flash of lightning, too faint to see, too quiet to hear. A goodbye from the sky. A soft, gentle, silent goodbye. Let us rest and think about lightning and the feeling of being small. It is a good feeling. Being small means you do not have to carry the weight of the world. You can let the world be big and powerful and mysterious. You can just be a tiny part of it. A tiny resting part. A tiny sleeping part. The lightning is big. The thunder is loud. The storm is fierce. But you are small and safe and warm and tired. And there is no shame in being small. Small things can rest. Small things can sleep. Small things can find peace in the shadow of larger things. So be small tonight. Be a pebble on the shore while the waves crash. Be a leaf on the tree while the wind blows. Be a single raindrop in the thunderstorm. Be nothing. Be everything. Be asleep. The lightning will take care of itself. The sky will take care of itself. You only need to take care of you. And taking care of you means resting, means letting go, means closing your eyes and trusting that the world will still be there when you wake up. It will. It always is. The sun will rise. The birds will sing. And the memory of this storm, this night, these facts will fade into the soft background of your life. Just another quiet memory. Just another gentle sleep. Now, as we continue gently, let us think about the very last fact about lightning. Not the last fact in this list, but the last fact you will ever need to know. And that fact is this: lightning is natural. It is not here to scare you. It is not here to punish you. It is not here to test you. It is just here, part of the sky, part of the earth, part of the beautiful, complex, messy, wonderful system that is our planet. And you are also natural. You are part of the same system. You are made of the same atoms. You obey the same laws. You breathe the same air. So you and lightning are cousins. Distant cousins, but cousins nonetheless. You both come from the same stardust. You both dance to the same physics. And when you see lightning, you are seeing a reflection of yourself. Not the same, but connected. And that connection is peaceful. It means you are not alone. You are not separate. You are woven into the fabric of the universe. And the universe is a soft, dark, gentle place, full of light and sound and silence. And right now it is holding you. It is holding you like a mother holds a child. It is saying, sleep. Sleep, little one. I will watch the sky. I will count the lightning. I will keep you safe. Just sleep. Let's take a slow, quiet moment to think about the feeling of completion. We have learned so much together. Over 100 facts about why lightning happens. About the clouds, the charges, the stepped leader, the return stroke. About thunder, about ozone, about fulgurites. About lightning on other planets, about ball lightning, about mega flashes. About safety, about beauty, about awe. And now we are near the end. The storm has passed. The facts have been told. The voice has grown softer, slower, more peaceful. There is a feeling of completion, a feeling of having arrived. You are here, at the end of the journey, ready to rest. And that is perfect. That is exactly where you should be. So do not fight it. Do not try to stay awake for one more fact, one more sentence, one more word. Let go. Let the last facts wash over you like warm water. Let them carry you to the shore of sleep. You are safe. You are loved. You are tired. And it is time. Gently moving forward, let us think about the space between the facts. The pauses, the silences, those are as important as the words. In the pauses, you can breathe. You can feel your body. You can notice the softness of your blanket, the warmth of the room, the gentle darkness behind your eyelids. The pauses are where the sleep lives. In between the words, in between the thoughts, in between the breaths. So do not rush to the next fact. Let the pauses grow longer. Let the silence deepen. Let the sleep come. There is no need to listen to every word. If you drift off now, that is beautiful. If you stay awake for the end, that is also beautiful. Either way, you are exactly where you need to be. Resting, learning, letting go. The lightning does not care if you are awake or asleep. It does not need your attention. It only needs the sky, the earth, the air. And you only need rest. So rest. Rest now. Rest deeply. Rest completely. Let us rest and think about the word goodbye. Goodbye is a soft word. It means God be with you. It is a blessing, a wish for safety and peace. So I will say goodbye soon. Not because I am leaving you, but because you are leaving me. You are going to sleep. You are going to a place where words are not needed. A place of silence and dreams and deep, quiet healing. And that is good. That is very good. So goodbye does not mean forever. It just means until later. Until you wake up, refreshed and rested. And when you wake up, the lightning will still be there. The sky will still be there. The world will still be there. And you will be there, with all the facts you learned stored somewhere deep in your mind. Not on the surface, not for a test, but in the quiet catacombs of memory. And someday, when you see a lightning storm, something will stir. A feeling, a memory, a soft voice saying quietly, gently, lightning happens because the sky wants balance, because the air wants to connect, because the earth and the clouds are dancing. And you will smile, and you will remember this night, this long, slow, peaceful night, and you will feel calm. Now, as we continue gently, let us think about the very last moments before you fall asleep. Your eyes are heavy, your body is warm, your mind is quiet. There are no more questions, no more worries, no more facts to remember. There is only the soft, dark, welcoming presence of sleep. It is like a door at the end of a long, gentle hallway, and you are walking toward it, slowly, softly, one step at a time. With each breath, you move closer. With each heartbeat, you move closer. And when you reach the door, you do not have to open it. It opens itself. It opens into a room full of soft darkness. And in that room, there is no lightning, no thunder, no facts, only rest, only sleep, only the quiet, steady rhythm of your own body doing what it does best. Healing, restoring, dreaming. So walk toward the door. Let your eyes close. Let your breath slow. Let your mind empty. The door is right here. Right now. You are almost there. Let's take a quiet moment to think about the feeling of being held. The earth holds you. Gravity holds you. The air holds you. The blankets hold you. The bed holds you. You are supported from every direction. You do not have to hold yourself up. You can let go. You can collapse into the support, into the softness, into the holding. That is what sleep is. A gentle collapse, a surrender of control, a trust that the world will continue without you for a few hours. And it will. The world does not need you to be awake. It needs you to be healthy, and health requires sleep. So sleep is not selfish. Sleep is not lazy. Sleep is necessary. Sleep is kind. Sleep is the most loving thing you can do for yourself. So do it. Let go. Fall. Trust the holding. Trust the bed. Trust the earth. Trust the sky. Trust the lightning to wait until you wake up. Or not. It does not matter. You are held. You are safe. You are loved. Sleep, gently moving forward. Let us think about the light behind your eyelids. When you close your eyes, you are not in total darkness. There is a soft reddish glow. That is the light of your own blood vessels, illuminated by the faint light that passes through your eyelids. And sometimes when lightning flashes outside, you can see that flash through your closed lids. A soft pink glow, a gentle reminder that the storm is still there. But it does not disturb you. It just passes, like a cloud passing over the moon, like a thought passing through your mind. You notice it, and then you let it go. You do not have to react. You do not have to open your eyes. You can just lie there with the pink glow on your eyelids and let the lightning come and go. Flash, pink, fade, flash, pink, fade. It is like a lullaby made of light, a soft rhythmic pulse, and each pulse brings you closer to sleep, deeper into rest, further from waking. So let the lightning sing to you. Let it be your night light, your guardian, your gentle, flashing friend. Let us rest and think about the sound of your own breathing. You do not have to change it. Just notice it. The air going in, the air going out, the slight pause at the top, the slight pause at the bottom. That is the rhythm of life, the rhythm that has been with you since the moment you were born. It has never stopped. It will not stop now. It will carry you through the night, through the dreams, through the deep, dark hours, until the morning comes. Your breath is your anchor. Your breath is your friend. When the world is loud, your breath is soft. When the world is fast, your breath is slow. When the world is bright, your breath is dark. So listen to your breath. Let it be the only sound you hear. Louder than the thunder, sweeter than the rain, more real than the lightning. Just breath, just you, just rest. Now, as we continue gently, let us think about the feeling of time slowing down. Right now, time is stretching. Each second feels longer. Each breath takes more time. The space between heartbeats grows wider. That is the beginning of sleep, the transition from waking to dreaming. In that transition, time becomes elastic. It bends. It softens. It loses its sharp edges, and you are floating in that soft time. Not late, not early, not rushing, not waiting, just floating. The lightning outside, if there is any, is also in soft time. The flash lasts longer. The rumble lasts longer. The gaps between flashes are full of quiet. Everything is slow. Everything is gentle. Everything is exactly as it should be. So let time stretch. Let it become a long, soft ribbon that you can rest on. A hammock of seconds. A blanket of minutes. A pillow of hours. Sleep is coming. Time is slowing. You are almost there. Let's take a slow, quiet moment to think about the absence of lightning. Not all nights have lightning. Most nights are quiet. The sky is dark. The clouds are still. The air is neutral. On those nights, you might miss the lightning. You might miss the flash, the rumble, the excitement. But the absence is also a gift. It is the gift of silence, of peace, of uninterrupted rest. On a night without lightning, you can sink into sleep without any distraction, without any reminder that the world is wild and powerful. You can just be, just rest, just dream. And when you wake up, the sun will rise, and the day will begin, and the lightning will be a memory, a possibility, a promise of future storms. But tonight there is no lightning. Tonight is calm. Tonight is still. Tonight is for sleep. Gently moving forward, let us think about the feeling of your heart beating. A human heart beats about once per second. A lightning storm flashes about once per second, on average, across the whole planet. So your heart and the world's lightning have the same rhythm. Thump, flash, thump, flash. You are synchronized with the storm. You are part of the pulse. Your blood moves like the current in the clouds. Your nerves fire like the stepped leader. Your breath is the wind. Your thoughts are the thunder. You are a storm, a small, warm, gentle storm. And like all storms, you need to rest. You need to calm down. You need to let the electricity drain away. So let your heart slow. Let your rhythm soften. Let the storm inside you settle. The lightning outside will take care of itself. The lightning inside you needs rest. So rest. Let your heart be still. Let your blood be quiet. Let your breath be shallow. Let everything be calm. Let us rest and think about the concept of home. Home is where you are safe, where you are warm, where you can close your eyes without fear. Tonight, your home is a shelter from the storm. The walls protect you. The roof protects you. The windows show you the lightning, but the glass keeps you safe. You are home. You are inside. You are exactly where you need to be. And home is not just a building. Home is also your body. Your body is the home of your mind, your spirit, yourself. And your body needs rest. It needs to repair. It needs to dream. So let your body be a good home. Let it be soft. Let it be warm. Let it be quiet. Let it be the safest place in the world. Because it is. There is no safer place than your own body, wrapped in blankets, lying in bed, listening to a soft voice, drifting into sleep. You are home. You are safe. You are loved. Sleep. Now, as we continue gently, let us think about the very first fact we learned. Lightning begins inside a cloud. Inside a tall, soft, billowing cloud. Ice crystals and hailstones, gently bumping into each other, exchanging tiny particles, building up charge. Slowly, patiently. And now, after all these facts, we are back at the beginning. The cloud, the ice, the gentle bumps, the charge, the lightning, the thunder, the rain, the silence. The cycle is complete. What ends is also what begins. The storm is not a line. It is a circle, a loop, a spiral of energy and matter and light. And you are in the middle of that spiral. Not at the center, not at the edge, just somewhere in the soft, swirling dance. And the dance never stops. It only changes. It slows. It speeds. It rests. It rises. And you rest with it. You rise with it. You are part of the dance. So dance softly. Dance slowly. Dance your way into sleep. Let's take a quiet moment to think about the darkness. The darkness is not empty. It is full of stars, full of planets, full of galaxies, full of light that is too far away to see. And it is full of lightning. Lightning that is happening right now somewhere on Earth, in some cloud, over some ocean or forest or city. The darkness is alive with electricity, but you do not need to see it. You do not need to hear it. You just need to know that it is there, that the world is still turning, that the sky is still working, that everything is in order, and you can rest in that knowledge. Rest in the darkness. Let it cover you like a soft, black blanket. Let it hide you from the light. Let it quiet your mind. Darkness is not scary. Darkness is rest. Darkness is sleep. Darkness is the womb of the night, holding you, rocking you, singing you a song without words. A song of silence. A song of peace. A song of lightning, far away, flashing and fading in the dark. Gently moving forward, let us think about the morning. The morning will come. The sun will rise. The birds will sing. The lightning will be a memory. And you will wake up. Slowly. Gently. Perhaps with a smile. Perhaps with a stretch. Perhaps with no memory of this long, soft night at all. And that is fine. The facts are not for remembering. They are for resting. They are for drifting. They are for the quiet space between waking and sleeping. So do not try to hold on to them. Let them go. Let them dissolve like morning mist. Let them fade like thunder. The only thing that matters is that you rest, that you sleep, that you wake up tomorrow or the next day or whenever your body is ready. There is no rush. There is no schedule. There is only the soft, steady rhythm of the world. and you in the middle of it, sleeping peacefully, deeply, completely. Let us rest and think about the moment just before the end of this video. The voice is almost done. The facts are almost finished. The lightning has been explained. The thunder has been heard. The storm has passed. And all that is left is this moment. This soft, quiet, sleepy moment. The moment before you close your eyes for the last time tonight. The moment before sleep takes you. There is no fear here. No anxiety. No excitement. Just peace. Just rest. Just the gentle, loving presence of the night. So take a deep breath. Let it out slowly. Feel your body sink deeper into the bed. Feel your mind sink deeper into silence. You are almost there. Almost asleep. Almost gone. And that is perfect. That is exactly where you should be. So let go. Let go of the last thread of waking. Let go of the last thought. Let go of the last word. And fall. Fall into the soft, dark, welcoming arms of sleep. Now, as we continue gently, let us think about the very last fact. And the fact is this: lightning is a reminder that the world is alive. Not just the plants and the animals, but the sky itself, the air, the clouds, the electricity. They are all alive in their own way. They move, they change, they respond, they create. And you are alive too. You are here. You are breathing. You are feeling. You are thinking. And soon you will be sleeping. Sleeping is not death. Sleeping is life resting, life renewing, life preparing for the next day. So as you sleep, the lightning will continue to flash somewhere else. The world will continue to turn. The sky will continue to dance. And you will be part of that dance, even in your sleep. Your body will pulse with the earth's magnetic field. Your brain will echo with the thunder. Your dreams will be lit by distant flashes. You are never separate from the world. You are always connected, always part of the storm, always part of the calm, always part of the beautiful, endless, peaceful dance. Let's take a very slow, very quiet moment to think about nothing at all. No more facts, no more words, no more thoughts, just nothing. The empty, soft, spacious nothing that is the foundation of everything. The nothing from which lightning comes and to which lightning returns. The nothing that is also sleep. The nothing that is also peace. Rest in that nothing. Let it fill you. Let it hold you. Let it carry you away. There is nothing left to say. Nothing left to hear. Nothing left to do. Only sleep. Only rest. Only the soft, dark, endless night. And the lightning far away, flashing and fading. Flashing and fading. Goodbye. Goodbye, everyone. Goodbye. It has been such a gentle pleasure to spend this time with you. There is no need to do anything now. No need to move. No need to think. No need to stay awake. If this video helped you rest, perhaps you could softly, quietly, with very little effort, like or subscribe. But only if you feel like it. Only if it feels as natural as breathing. There is no pressure. Only peace. Only sleep. Good night. Good night. Sleep well. Very, very well.